Ein herzliches Willkommen an die Forth 2020 Leute. Hallo.
Ja, wunderbar. Vielen Dank, Gerald. And so that everyone can understand the presentation of the German Forth Interest Group, ForthGesellschaft, I will give my talk in English. And let's share the screen so that that's the big blue button meeting system that we use over there at the Forth-Tagung. And so let me see that I can actually get the appropriate window. Yeah, here we go, ForthGesellschaft. And we have a very lovely web page that describes many aspects of what ForthGesellschaft is actually about. So it's it started maybe as a national Forth interest group, but it's now just about the German-speaking Forth enthusiasts. And so the web page is in German, but of course what you always can do is translate this with Google Translate. And then you can approach this as well. So we have a blog-like structure where we talk about our findings in the Forth community. And then there's also, so that's the blog, and there are links to the appropriate sites. That's interesting. So it's about, it used to be 200 people in Germany that were member. It's run as a official club. And so on this weekend, we will also have our formal club meeting tomorrow morning, where there's a director team that makes decisions, and we collect fees from the members each year, so that we can do appropriate things like buy some microcontroller boards that we lend to interested people, things like this. Or if we find some challenging hardware, then we sponsor this so that a Forth system is ported to this, or things like this. Right, and then we run the longest magazine in printed form, the Fourth Dimension, Vierte Dimension, which is just a wordplay in German. It's not fourth dimensions, but as the number 4. And there's an archive of all the issues. So you see the first issue was in 1984, and we ran for more or less every year 4 issues of the magazine. And you can just go ahead and click there, and it will fetch, well, it might fetch the appropriate magazine, and then you can go ahead and have a look. Of course, many of the articles are in German, but we strive to have one article at least in every issue to be in English. And again, you can use one of the translation services to get this. And my experience is actually that you will get at least a good idea of what's going on. So it's original material that the members typically publish there as well. So that's the Forth magazine, and we probably tomorrow have a discussion of whether we want to continue doing the print issues, creating at least the PDF, and this is a discussion we do every year. And it's so satisfying if you get a paper copy of the magazine, so that I'm still in favor of getting this. You get this envelope and said, well, yeah, here's the Forth magazine. So that's actually a great thing. So, and then what we do is we do our meetings, unfortunately this time online, as has been done last year. But in normal times, we travel around and in Germany and in different places in Germany, meeting there for Friday, Saturday, Sunday. And for me, this was a great challenge to travel around in Germany and to go to places where I haven't been there. So it's also, yeah, we were in Essen, we were in Bad Vöslau, which is not Germany, but Austria. But the ForthGesellschaft has extended to the German-speaking Forth entries, as I said. And then we also visit maker fairs to present our stuff. And for all these things, then we collect photos, so you get an impression of what our activities actually are. Of course, everyone is free to join us. So if you want to brush up your German, then you can apply for membership, and that would be easy to do. Then there are lots of projects that we do. So there's a wiki, and I already translated this page, as I see. There's the wiki that we manage with projects and ideas and additional information about things that you can't retrieve in other places in the internet. As I said, we have lots of meetings, had lots of meetings, and you can see it goes back to 1984. Every year we meet, we've met at some other places. Right, and maybe a very important thing is that we have thought that swap is our favorite character in related to Forth. And so there's even a Swap Dragon award that is given to a person that has done good promotion of Forth, done a good service for Forth in the last year. And there's even a bronze sculpture that is a sculpture of swap that you can actually get if you get the award. So it's also like we do, traveling around in Germany, being in the different homes and so on. And as you see, there are lots of people that received the swap award at one time. So yeah, I think that is my short presentation of what ForthGesellschaft is about. And so we are currently, as you see, we have also one meeting room that is Swap's lair. So it's always with us. And tonight there will also be the meeting of all the people that have been awarded with the Swap Award to think about who will be the next one. Right, so I think that's it. And so if you might to comment or have some questions, we all probably are happy to answer them. So are there any questions?
I am grateful to ForthGesellschaft because I learned with you. You didn't know me, but I received your magazine in South America through a friend in German, and it was a great content. In my young days, I learned a lot with all of you.
I have a question, Uli. How much does it cost? Do you feel costed less?
Yeah, I currently I don't know. We always strive for powers of 2. So it could be
65,536.
Yeah, could be. No. And we try to be below 100 euros a year. So it could be currently 32. It could be 16 or something like this. It's not 64 because that's probably too heavy for many people to. Yeah. Well, what you get is actually the paper copy of the magazine. And of course, you're welcome to join the conferences, which are your anyway. So, yeah. So it's mainly the magazine and accessibility to maybe the microcontroller landing service or borrowing service and things like this. So if you want to play with some RTX 2000, then the ForthGesellschaft has a board. You can try and experiment with it. So that's the idea.
Sieht sehr gut aus.
Not the power of 2. It's 40 euro per year.
Ah, okay.
Because we had to raise the fee for printing costs, and It's 64 would be too much, and 32 is not enough.
So it's it's a power of 2 for certain values of 2.
Yeah, well, it's not an integer power of 2.
Exactly.
I think that
everything's
that
a
was the
power of
comment
2.
in the
Yes.
end.
Yeah.
I was actually curious if there was I'm sorry, I was curious if there was an STL of that swap dragon available for some 3D printing.
Yeah, is Mattia, Friedel Armin printed already one. Can show?
Yeah, but
this is Friedel's printed version of the
great.
force, and if you ask Friedel, you can get his data for it. So it's possible to print it.
Yeah, and I mean to spread swap in the world. That's what our task is. So every German club needs to have a purpose, and to be non-profit, accepted, and tax reduced. So we need to have a purpose in the area of education, social education, for the society, and our purpose is actually to spread force and to make it popular, and so that people know about it and its advantages. So yeah, that's the idea.
I might have missed this, but how many members do you have?
We started with 200. I think it's below 100 by now. Yeah. So unfortunately, it also started that members died of age or of illnesses, and it's actually an issue. So how to convince young people to join a club, which club is so 20th century, and it's not so easy. Yeah, and and also, well, that's something we also face in the international community, how to attract people, young people, to even consider doing stuff with force. I'm convinced if they do, they will find the benefits and see why it's good. But to get them interested in the first place is actually a difficult thing.
Yeah, and even when we get them interested, joining the club is another issue.
Yeah.
Because that's so 20th century clubs. And they say we can get every benefit except the printed magazine, and the young people don't need the printed
Who needs
magazine.
this in the first place? Yeah, right.
Who is printing out the internet? That are the old people with Kugelschreiber, we say in Germany. So
yeah.
I think we get the most. I think we get most interest at the maker fairs and even more at the CCC, where we have more time to explain it to the people.
Yeah.
Yeah, so that's also one of the actions. There's the Chaos Communication Congress taking place in Germany every year from Christmas to New Year. And we regularly be there and talk to hackers or people that join the conference as well, and tell them about force. And that works quite well.
Except during the pandemic, of course.
Yeah. So online is always also for these kinds
the last year online conference of the Chaos Communication Congress was unofficial. So it had many people there, and it was more chaotic than you expected from the name Chaos. But this year they want to try again with an online conference. Maybe it will be better. It's difficult to have an online conference with some 1,000 participants.
Yeah, maybe we should also explain. Normally, people walk around after the presentations, and there are lots of assemblies. So every little community has a stand or something, and it's just very cool if a young teenager sits next to you with a bright mind and is open-minded about force, and you explain it to them. And some of them say, it's nice, but I will stick to MicroPython, and that's fine, right? But at least now they've heard the name, and some of them are like, oh, wow, that's an interesting one. And can you give me a link? Can you give me that? And yeah.
I will tell you, I will give you an idea. We have Pablo Reda in our group, and he is teacher for young guys, and he created a force to make games. If you make that, you speak to the young people, because no of the older people except Mateo, he is interested in games. But you speak to the young generation. If you make a force for games, you are speaking directly to these guys.
Exactly.
And Pablo brought to our group a 14-year-old guy, and also SVFIG has a 17-year-old guy who he will present today, Xuyang.
Very good. Cool.
I'd like to say ForthGesellschaft is the first publication who wrote about my language, and I say thank you to the German group.
Thank you very much. My Spanish is much worse, or Portuguese, or whatever. So I couldn't even say a complete sentence there. And yeah. So great. Yeah, maybe we should stay and get in contact still to see what things you actually do with the pupils, and what kind of games and what platform you use. So that could be interesting.
I start programming, making games, and this is the path of I follow to learn, and I try to explain to children how programming with the excuse of making games, and this work, and when in for now.
It's one of the best excuses, I think, to learn programming.
Yes.
That's
For kids, it's fantastic. Yes.
That's literally how I started it as well. You know, it's like when you start these things, it's often the first thing you want to program. A teenager, anyway, is to write games.
Yeah.
Go ahead. Yes, many years ago, I think it was in the last millennium, I saw 2 games of children that were written by Pablo's Forth. And I remember one game was of a boy who collected worn-out papers in the city, and he was steering his bicycle through the traffic and has to be careful not to be hidden by cars.
Exactly, Martin. Very well. I knew Pablo the same in YouTube. I met the work of Pablo. There was a crisis, a very hard crisis in Argentina in 2000. And Pablo's idea was fantastic because he took old computers which could run Forth. No other program would run in these old computers for poor children. And so it was a fantastic work of Pablo.
Thank you.
I just wanted to ask a hypothetical question. Is it actually possible to write any program in Forth without the process of writing the program being a game? It's all so much fun. I mean, it
depends on the customer, doesn't it?
Yeah.
And then on the task, because if your task is to fix somebody else's program, it might not be a game, but it's more of a haunted house.
No.
Well, then it's like a Rubik's Cube.
Yeah. Yes. Often what seems to happen is that the problem to be solved is like a Rubik's Cube, and it comes pre-packed in its box with all the colors correctly aligned. You know, the problem solved, and you hand it to people and they scramble it for you, and then you have to put it back again. It's like they make life complicated. Anyway, so I'm rambling. Carry on, everybody else.
I think the actual problem is the library. You need a library for make a program, and all the libraries need more person, more money to develop, and we, the 4 programmers, not have the structure to make library for any hardware piece in who sell, and then it's difficult for us use, for example, for not talk about hardware. When I start, I need a chip PNG encoder for graphics, for load graphic library, and not found the program for load this image format, and it's a common library for any other language, and then I need rewrite all the code. And this is for some people, this is good, but if you need make a game, you not need a program for a format, for a graphic format. Then is a problem, but I don't know how attack this problem. I don't know if you understand me.
Yeah, I wonder, are you saying maybe if there was a way to interface with, let's say you had a library in MicroPython and you wanted to be able to call that from Forth, is that what you're, it would be interesting if there was a way we could interface Forth with the other.
I think what Pablo is saying, he's saying we should share in Forth libraries, in Forth, written in Forth, not from other languages.
Well, I think both. I think it's a good idea, because if you look at like MicroPython, when you want to write a program, you have like a library directory and you drag and drop the. So yeah, so if you had like .fs files that were your Forth drivers, you drag those into your program, and now they're available for you to call from your application. Because I've found that myself. I'm just starting out in Forth, and that the big struggle there is like, if you want to interface to some LCD display, you have to almost write the code yourself to do that, which, you know, if you're in MicroPython or CircuitPython, that's already there. You're able to avail yourself of that. And the point I was trying to make is, if there was a way, if there was a MicroPython driver for a certain display, if there was a way you could bring that into your Forth project and be able to call it, you know, put parameters on the stack and then call the library function and have the library, you know, maybe have an interface layer that takes the things off the stack in C and, you know, makes the call and then returns the values onto the Forth stack. I think that might be of benefit. Of course, I don't know how easy or difficult that would be to implement.
Well, if you've
one of the things that was particularly interesting to me in Forth and getting just new into it is the linguistic way that the programs are written, how it's very easy to write essentially sentences for your program. And I found that people weren't very interested in the idea of logging in through a UART terminal and getting access to, you know, typing directly into a REPL. And with CircuitPython, I think there's more opportunity that newer programmers are getting into the idea that they have a REPL, that they can work with this constantly rather than this program compile test debug cycle where they can be actively in there. So I think the CircuitPython is an avenue for people to get into. You know, I don't know if it would be some kind of Forth almost virtual machine on top of CircuitPython. But I think the linguistic nature of the way Forth is written, I think, is a major benefit to. I think that would be very interesting to people.
Paulo, I have a question for you. Have you written JPEG encoder in Forth or in another language?
Yes. I write the encoder and decoder, but translating for C. Is
not in Forth then, not in Forth.
Yes, in Forth, but translating the code C to Forth.
And is it possible? Is it possible to share this code in a library? Can we share this, for example? There is a Forth.
It's in my site.
In your site, okay.
But it's in my Forth, not ANSI Forth. Okay, it's the color Forth derivative.
Well, but this could be an interesting contribution for the Forth community if we put this part of your code separated from your REDA Forth as an ANSI Forth. So everybody in the community can share this and use, and other people, we should encourage other people to do the same. So we will have in Forth a lot of libraries, like Trey is explaining from MicroPython.
Yes, I think when you program in Forth, you need rethink the problem. And with you code in Forth, you learn about the problem. And if you go back to C or Pascal or whatever language, you redoing the algorithm. Sure, for me this happens all the time.
Fantastic. Gerald is calling us. Gerald.
Okay.
I would like to add that we actually have some C interfaces also working in ANSI C. So maybe I can show one of them, because I am the author of the Forth module for the simple wrap and interface generator SWIG, where it's very easy to import all kinds of C functions into the Forth world. Unfortunately, though, I think we have to go on with the ForthGesellschaft meeting now, and we have to leave you, because the discussion is very interesting. It was very nice seeing you all again. And I hope we can continue this in the next meeting.
Later, yes, fantastic.
Right, so for now we split, and there will be a common talk later on from Willem, myself, and Jeroen, and we will join again. No, I will give the talk in both conferences simultaneously. That's the idea, so yeah, I will be here and there, and wish everyone a pleasant conference and many new thoughts, and yeah, a good impression, and lots of Forth work.
Fantastic, Ulrich. This part was, I thank you very much to ForthGesellschaft. I have no words to say thank you for all of you guys. And have a nice meeting.
Okay.
Bye-bye, Gerald.
See you later.
Bye-bye. See you later.
Bye.
Okay, so we are going, guys, we are at Forth2020 meeting, and our program tells me that Peter Jakacki will begin with Tachyon Forth internals. Is it okay, Peter, for you?
Yes, all good.
Okay,
all good.
Go on.
All right, so I'm going to use my share over here if I can. I'll just put that through, and I'll just give you my screen if I can see it. I don't know what's happened here. Wrong screen, right screen. Okay, all right, I can see that up there. So you can all see that screen clearly. Good. Well, I've just made it so it's just standard HD. And for some reason, I see what's happened over here. I have a few different screens going, and I tend to confuse myself a little bit, but bear with me. And so So talking about Tachyon, what is it? It's Forth, but it's Forth for our little micros, all those little boards that we do, that we build into products that get buried in a box, in a building, in a basement, on the side of the road, in airports, in all kinds of equipment. And it has to run 24/7, 365, as we say, reliably. And it has to be, so it has to be a turnkey type operation, industrial strength. But we're not talking about a commercial type compiler. We're talking about something that is custom. So I started off with the, some of you may be familiar with the Parallax propeller. It's a little 8-core MCU. And so I was programming in Spin when I first played with this. This is back in 2006, and it's a really nice little chip, but it's only got 32K of RAM, and it loads up from EEPROM from I2C bus into that. And now what happens is that we're programming in Spin. We can do this, hit the F11 button, compiles it, loads it down into the board, and it's running it straight away. Nice and easy, very simple. Very compact, but here's the problem. It's difficult to mix in any assembly code. It has to go into another CPU on there, another cog, as we call it. And Spin itself is not all that fast. And so lots of different reasons. I looked at a couple of different Forths that were available. I'm just cutting this down very short, just to give you a brief introduction for this. And so they were too slow. They weren't really workable, and they weren't ones I could embed into products with any confidence. So I started writing a Forth. I've written a few before. Propeller was very different. One of the things I wanted in here was that it would be compact and it would be fast. And in fact, I wanted it so that whatever application I wrote, I'll look back on some of my old applications. I had lots of code modules in assembly code just to make them run faster. And I didn't want to write any assembly code. I just wanted to have the instructions and everything else built into it to make it real easy to work with. And so I came up with the word Tachyon. We know, it's basically saying, look, it's fast and it's really small. This is all I'm really trying to say with it. But as we can see from up here, it was optimized for that turnkey embedded systems. And really, when I first started on Forth, they were on 8-bit CPUs. And we're doing 16-bit Forth on it. It was horrible, really. And it was good to have 16-bit CPUs, and now at 32-bit CPUs, this is really great. So what did I do with Tachyon to make it a bit different? Well, I like, I hate debugging. This is what I hate doing. And using your logic analyzers to find out what's going on, why did it crash, etc. So one of the things it had to have was a return stack that was just a return stack, because if it tries to return and there's something on there that shouldn't be there or whatever, it's really going to crash. And so I had, and traditionally Forth has always just put, hey, let's put everything on the return stack. Anything that's not on the data stack is on the return stack. Very messy. This is an embedded system. It's not a desktop PC. So straight away, I also did a loop stack and a branch stack. I combined those together. Basically, the index and the limit and the branch to a loop is on that loop stack. So we have 3 stacks, nice and easy. We can still use a return stack for other things if we really want to, but I prefer not to. The other feature it has too in here are 3 memory spaces. I wanted to keep the code separate from the variables, and in fact, the dictionary itself, all the names and headers that would traditionally at the start of every code word, every word, totally separate. There's a good reason for this. I will come to that in a moment. And so too, initially when I wrote Tachyon, it was a bytecode model. It was nice, but as the program grew, it got messy. I came up with word code, which is basically 16-bit addresses everybody loves in Forth, except it's internally, it'll decide whether it's assembly code or it's has to be threaded, or perhaps it's an encoded literal. So we have this 16-bit hybrid address code and mixed references, as someone said. Now, with the dictionary, coming back to the dictionary, one of the advantages is that this is what we want to do, is we put it in a product. We don't want people getting into it, seeing the dictionary, oh yes, we can work this out. So we can remove the headers, we can put them back in, we can do all kinds of things, or we can make some private that only necessary perhaps when we're compiling. Once we're done, we don't need them anymore, we can strip them out. Having the dictionary with all the headers together in one space made it very easy to do. And so we can even move that out of the way. And so what happens is the code is building from memory up, and here's a dictionary coming down. And when it gets too close, we just say, look, let's just move it somewhere else, or squeeze it up, or reclaim some of the private headers, etc. we can strip out. So that made it very handy to do that. Now, the other thing, we mentioned 3 memory spaces, and we have the code, we have the dictionary, and what about variables? You know, in Forth, it always says variable. When I do assembler code, it's like I say how many bytes or longs or words, you know, 16-bit halves, etc., that I need, and I expect them all to be together in one part of memory. I can erase all that, initialize it all, and if I do that, it's nowhere near code. It's not going to affect it. So I have a separate area just for the data as well. And so what happens, it's not intermixed with the coded dictionary, so it's quite safe. I've had very funny bugs where I've written 32 bits to an 8-bit variable, or a double to a 32-bit. Not pretty. You can imagine with headers and regular Forth code, that can kill everything. Now, this is the other really nice feature that we have in here, and I can show this to you in just a moment, is what I'm just calling complex for want of a better word. But we mentioned, before it was mentioned about the REFL, the read, evaluate, print, loop. That's not how Forth works. We type in a loop, etc., it gets compiled and it gets run. But we can't do that from the command line. Why not? Well, that's because it's interpreted. Why is it interpreted? I don't know. Why can't we just compile it? It already does it. As soon as I say colon, new word, do this, loop, it compiles it, and then I can run it. So how about we just compile it as normal? And when I hit the enter key, because I didn't define a new word, it just says, I'll just run this. And I remembered where I started doing this, so I'll reset that pointer for the code dictionary. So what do we end up with? I'll just show you very quickly. Everybody can see that terminal up here, this one up here. Is that all okay? I might make that a bit smaller and bring it up a little bit more. Okay, so here we go. All right, so we're talking to Tachyon operating system on the P2 processor, or Tarkos. It's built into the ROM, but this is a version loaded into memory. I just reset all that, and it's booting up, and it's talking to me now. So what I'm going to do is, you've always wanted to do this. I know everyone's wanted to do this, but basically we come along and we type in a loop. What sort of loop shall we do? We'll start from character 2. Well, let's do it back to front. 80202. We're doing printable characters. And what I'm going to say is the index, emit, loop. You can't do this. This is on a REFL, but here you can. Can I put in conditionals? Sure, anything. Can you say print hello world? Oh no, you have to have a special word for that, don't you? No, you don't. Look, you know, mind you, I also have clear type words, but of course they're exactly the same. Oops, but don't worry about this. We got that hello world. And so what I like to do is have words too, by the way, when just as you see that 1, 2, print, 1, 2, print. if I'm writing source code that someone else has to read, me included, I use the clear type print and all these sort of words like that. But if I'm just playing with it, I use the little shortcuts. They're nice and quick. Now, this is how it works. We can just, anything we want to test out, we want to do a little loop. If I had a little IO pin and I wanted to run through it 100 times, I wanted to go through it 100 times. I wanted to go through and make pin 31 high for 10 microseconds, and then 31 low for 20 microseconds. If I put the scope on that now, I'll just see 100 pulses coming out exactly just like that. If you do that with, if you could do that with a REPL that interpreted, what would happen? The 100 would be interpreted, then it would go off and search for the 4, and there would be these big delays between each and every word. There's no need for it. So what we have is we have this compile, interactive compile and execute. It's totally transparent, as you can see. Still does everything we expect it to do. Why wasn't it done in the first place? I don't know, but I'm doing it now. So it's a good idea. We love it. What does it enable us to do? I mentioned in here M2M, machine to machine scripting. Someone mentioned scripting before. This is how I sell Forth sometimes. It's great. You can talk to this and we can write little macros and scripts and everything else. And one machine can go send a script. And because it's compiled, we know it's going to run at full speed. And also because of the way it compiles, it responds very quickly, low latency. So that's one of the advantages. And of course, when we're testing out hardware, we can do this very quickly too. Now I see my time's coming up. Oh, good. I've still got a bit of time. I haven't gotten very far through this, but also might just mention too, Tachyon, I like to have that flexible input and output as well for the numeric input. So we're all used to the decimal numbers, 1, 2, 3, 4. There we go. And then we have, are we still up there? Is it still up there? It seems to have disappeared. There it is. And then we have the hex, of course. There it is. We have binary. We know binary, etc. And I also allow for mixing symbols in with that. If I want to say this is a decimal number, but it's P20, I mentioned before, 31. That's okay. That's 31. Why invalidate the number? It's a perfectly good number as long as it abides by certain rules. Tachyon won't search the dictionary. It will just say, this is a number. I've got it. Bang, compiled. So that makes it a lot easier. And of course, look, the other thing we like to use are things like this. You recognize this, of course. What is that? Well, there's a few different terms for it, but you know, we can see each group of decimal digits represents a byte. So IP notation, and so when we print that out as a hex number, we see there it is. So we don't have to guess. And another thing we can use this for, and I use it all the time, encoding 4 pins into one long. So I can specify the pins to use for SD cards or any other device, etc. I do that quite often. So it's a nice flexible format. What does a dictionary look like? Let's just do some words up on here quickly. So there's a few words in there. It's telling us what modules are loaded. I haven't got too much loaded at the moment, but it's just looking for in here. It's just looking for all these words in here that have that particular format. And it says, okay, this is the name of a module, executes it, prints it out. So I know what's loaded in there, and there's 0 delay for loading things in. So I just say, load this in, it compiles within a second or two over the serial port. And this one is communicating at 921.6. But I have tried this out at 8 megabaud, works really nicely at 8 megabaud too. So we have a lot of things built in, and also to the filing system as well. We can do that. We can do a directory, etc. Perhaps not enough time today to show you all these different things because I'm running out of time, but I might just have a quick look at my document now just to remind myself. about this. So we have the compile and execute instead of the REPL. And in here in the red, well, these are the negatives about it, processing of numbers, etc., different things. So it's far from instant. Why do we use it? Because it's traditional. Well, even Chuck isn't the inventor of Forth. He's not traditional. He'll do things very differently. So that's the solution. We come up, we compile it just like we normally do in Forth. And there's a few examples. There should be a link to the document on Forth2020, but I'll fix it up if you don't happen to have the link to this particular document. Very easy to do. Once you understand the principle, there's nothing else to it. It's very easy. So, and the other thing I do when I compile, I don't wait for the full terminal buffer. I just compile word by word. As a word comes in, it's compiled. By the time the end of the line is reached, it's ready to be run, executed. So, pointed out before too, they have the data stack, the return stack, and the loop stack. I didn't demonstrate that, but I'll just have a quick look at the stack. There's my timer going, so I'll try to wrap this up very quickly. But we have the stack up here. And so what happens too, we have the loop stack. I think I can perhaps print out some of these things. I'm not quite sure where they are at the moment, but the loop stack lets us do this. Watch this. I say print index. It's I print. Okay, nice and easy. And therefore I do a loop. I'll say 10, 0, do print index. You can't do this normally in Forth to access the index externally or affect the limit or leave the loop, etc. But you can do that because we have a separate loop stack. It's not mixed in with the return stack. So obviously, I'm not even going to get through a tiny fraction of this document. It's available, and if you need the link, well, we after the meeting we have a little bit of chat time, and you can ask me questions about this. But there's lots of little things built into this that make it very easy just to get a new project going. To me, they tell me we need this yesterday. I say, well, I had it ready the day before. Because it's that easy just to test things out, and I have the confidence that once it's out in the field, I can make adjustments to it very easily as well. So thank you for your time, and I've definitely gone over 15 minutes.
Fantastic, Peter. Thank you so much. We need to change the, if you stop the screen sharing, we change to Bill Ragsdale. He has a presentation about add impact to your first video presentations. It's okay with you, Bill?
Ready to go.
Go ahead, please.
Good, thank you. Delightful to be here today, joining our group. Get a couple of clicks going here and we go to the screen. So today we're going to be discussing, does my screen show properly now? You see everything?
Yes, perfect.
Very good, thank you. So the presentation today is going to be how to maximize the visual and information content of Forth programs when done on Zoom. The recognition today is that for Forth2020, Zoom is our platform and our medium. The physical meetings are difficult. This is a worldwide venue, and so we need to make the most effective communication value using Zoom. Increasingly, Zoom has replaced print as an archive also, because these programs are recorded and then available for replay later on. So you need to have good information content in your Zoom presentations because it's forming a long-time archive. So let's make the most of that use of this medium. We're going to focus today on the clarity and the utility of our presentations. And we remember that while we're doing this, we're doing what I call a deep dive into technical topics. We're doing complicated concepts, sometimes on screen, a little bit hard to follow. We want to make them as clear as possible. And also we're on a time limit, 15 minutes today for me. So we want clarity, we want depth, and we want to hit our time schedule. So here is one of the difficulties I encountered. Sometimes we'll get someone giving a talk, scrolling their screen, showing down an entire page of code or a long scroll that on their screen is adequate, and it's what they would do for editing, but it doesn't work that well for presentations. The only one who could attempt to hold your attention for 20 minutes off of a screen of code is Chuck Moore. So we shouldn't try. So some of the tools we'll be using today is we're going to advocate using a proven structure for the format, using effective communication methods, breaking the information into smaller segments to fit on screen, and finally maximizing the use of the screen, maximizing the functionality of your camera and the text. So I'll offer a very simple structure for a talk. This is about as simple as you can get. First, you tell them what you're going to tell them. Then you tell them. Then you tell them what you told them. Another way of looking at it is to say you have a beginning, a middle, and an end. Or another way is you have an introduction, you have a main topic, and then you have a summary. Now, on second structure that I picked up doing some kind of research when I was about a junior in high school that stuck with me all these years is SAFW, the SAFW model. The S stands for state your idea. A stands for accentuate your idea or details, broaden it out. The F is for instance your idea, give examples, give applications, and finally a conclusion, wind up with your idea. So SAFW. So I'm going to offer one overarching concept or factor to bear in mind as you do a presentation. If you skip over all the things that I talked today, one thing to remember is to state for yourself, what is your intended outcome from a talk? What information do you want to convey and how do you want to convey it? And think that over before you start your presentation. It will add clarity and structure. So some of the possible intended outcomes, one would be to transfer a skill. Another one is to expand details for the experienced programmer. Another one is to announce a discovery or something new or novel that you would like to present. Another might be a discussion of a topic from both standpoints, a pro and a con debate. Or another one might be to present an overview of a topic. And guess what? That's today. We are presenting an overview of the topic of enhancing communication. So here's a little mechanics on how the brain works. In a very simple way, we find there are two information paths to the brain. One is visual, one is auditory. Of course, there are others too, smell, sense, taste, and so on. But we have a visual input and we have an auditory input. But the remarkable thing is that visual to the brain means images and pictures. So when you have visual input, the brain processes images and pictures through its own path, but not text. It turns out that visual, text, reading, and hearing share the same path into the brain. And the other one element is that the reading phase will override hearing. You might experience this if you're late at night trying to read street signs as you're driving. And as you're visually focusing on reading those words, you'll turn the car radio off or tell somebody to stop talking. I'm trying to read those signs. The reason is it's sharing the same path to the brain. So the implication of this is that if you're going to show a slide with multiple bullet items, the listener or viewer will read ahead while you're talking and miss your comments on point one. So the answer is, or the components are that to remember visual leads listening. So the visual takes place first if they're simultaneous and the listening comes second. So that means reveal text only as it is needed. Or a possibility is to reveal all the bullet points and then pause for a few seconds while people read them, and then we begin talking again. And you see, of course, I just did this in this slide. I revealed these elements one line at a time. So we need to focus on how to hold your viewers' interest. If you're in a workshop format, a classroom, a conference, people are gathered around, they're taking notes, they have work tables in front of them, you have extended presentations, you have breaks. In that case, you can put more detail into your slides. But if you're doing a brief presentation like I am today, try to hold no more than 3 points on a given slide. Pardon me, no more than 3 points in the talk itself. And limit to somewhere in the range of 15 to 20 minutes. And I say this format now is in a 15-minute format for Forth-2020, which works ideally. And remember that the very popular TED Talks are 20 minutes for a reason. Looking at some of our fourth issues, if you do the full screen presentation scrolling as you would edit, there may be an idea that you want to emphasize that I've outlined with an arrow. But if this is your screen size presentation, it is very hard to read, and it is even harder to focus the reader's presentation because they will be reading and looking at code, not where you're talking. So how do we solve that? Well, first collapse your window down on your editing area to just the idea itself. It will be small on your screen, but the magic of Zoom will expand that to a full screen. So your small window will become full screen on the viewer's screen, and all the detail is clear. Your idea will be have impact and be clearly presented. Here are some techniques to get the most from Zoom. There are a number of little buttons all around you need to explore. I can't go into all the detail of which button to push to get what item, but explore Zoom. It is a rich capability. The elements that are important is first to simplify your background, get the best lighting possible, and then use webcams to show your projects on a tabletop basis. And video lighting can be a very complicated topic. It can be a professional career. Today, I'm going to talk about just the very, very basics of illumination for video. And that is to be sure that your face is clearly illuminated by more than room lights. Room lights and window lights will cause shadows, and you will, again, you'll have clutter in the background. Secondly, is to simplify or eliminate the background, because I used to have a model airplane over my shoulder, and people would sit there and look at and comment about the model airplane and then think about flying rather than focusing on the topic that I was discussing. Let's see what improvements can be made. This is a basic starting point. You see the black wall behind me, overhead lights, shadows coming in from the window, not particularly clear. First, I'll turn on a facial lighting. There we go, better view of the face, puts the emphasis where it ought to be. Now, some people go to a pretend background. This is the one I like to talk about with my spa and the indoor pool in my backyard, which is total fake. And again, it distracts from the presentation. Much better to go to a plain black background. And this is what I always use for presentations. You focus on the person, the face, what they have to say. And here's how I do that. I have a simple desktop lamp above my computer facing directly at me. It's not a single bulb, it's an LED loop lamp. The it's shadow free. And then I put a tissue paper over the front of it to minimize the shadows and the glare. To add vitality and interest to your presentation, consider using more than one camera. Right now, I'm using the integrated camera on my computer, but I have attached a Logitech webcam. Costs about $85 and works exceedingly well. With a simple click, I can move over to the webcam. And now we're able to look at the project area, and we can share all aspects. And a simple click moves us back to the integrated camera for the rest of the presentation. If you go further on this, rather than just using the camera in your computer, consider using live streaming software. The contemporary versions of this software interface perfectly with Zoom. Instead of going to your desktop, you go to the live streaming software, and it takes over all control. You can integrate then slides, desktop, video, audio, switch cameras. The one that I use is XSplit Broadcaster. It's $5 a month. There's a free version with more limited features. The similar one is the Open Broadcast Studio. It's free. When I began looking at this, I saw better reviews from XSplit, so I went to it. I don't mind the $5 a month, and the flexibility is great. This is what the XSplit screen looks like. What the viewer sees is just that live video in the center, and what you see on your screen is all the surrounding tools and functional areas. The key element is at the lower right corner, there are what they call scenes. Each scene is a setup. The one right now shown in blue is just a straight video camera. When you click on the second block that's blue, now you can mix your face and your presentation together, or you can bring multiple pictures together. And I could even have a live video camera linked to the screens of my slide. And then finally, another click takes me to the portable video cam. You can move back and forth between these with one little simple click. And the integration of video and audio is great. So to summarize, to add impact and clarity to your presentation, plan for a structure at the beginning, follow one of the simple models, adjust the depth of detail that you want to show. Are you going to do overview? Or are you going to do small details? Budget the space and the time. Make sure that your code comes out large on the screen for visibility so that the viewer is reading what you want them to read when you want them to read it. Optimize your lighting and your background for clarity, and then consider hand camera for demos. Rather than holding up an object in front of your computer camera, get a portable handheld camera. And our benefits, the entire goal is to optimize information transfer, hold people's interests, get the information across, hold their view. And remember, we're generating that long-term archive of Forth technology. So what we say today will live in the cloud for generations to come. And we want you to be able to get the best use of resources that you have right now, simply your computer, software, and maybe a hand camera. And by the way, I want to point out that today I used the SAFW model. First, I stated that Zoom was our communication medium. Its advantages and why we want to use it. I accentuated the communication factors that enhance the use of Zoom. I, for instance, this by offering several tools that you could use. And I just wound up a moment ago with the benefits. So you see the SAFW model does work. So thank you for your kind attention. Later in 1 week, I'll be presenting this at the Silicon Valley Forth group, and their archive is located as you see here. So if you wait about 2 weeks, you can see a video and the slides of this presentation. It's at the forth.org/SVFIG, and at that page, you will see one line that says past meeting slides, video, and notes. And at that is a record of about the last 8 or 10 years of the Forth Interest Group's presentations, both the slides and the video. Or you can go directly to it by forth.org, SVFIG, and then kk/kk.htm. So I hope you'll be enhancing your video presentations. And do we have any questions briefly?
Thank you very much.
Fantastic. Don, sorry, Bill, when is the fourth day? Next week or in 15 days?
Next week. Next week. Due to calendar, the fourth Saturday, the fourth Silicon Valley Fourth Group meets on the fourth Saturday, except for November and December on the third Saturday.
Okay, I will be there.
Okay, are there any additional questions?
We're in stunned silence. That's good.
Yeah, so.
Christian has a comment.
There are.
Bill, you did a good job because I didn't chat at all while you were talking.
Yeah, Bill, that was really great. On the road again.
Yeah.
So
oh, sorry. Go ahead.
I think I have a question. So you talked about Open Broadcaster Studio, and do you find it easy to operate the Broadcaster Studio at the same time while you give your talk, or is the main work done already if you define the scenes and then you just go ahead and switch them?
XSplit uses what they call scenes. Each scene is a setup, and it can be images from your screen. It can be a live window. It can be PowerPoint, or it can be individual cameras. So the first time I used it, like most software, the first several hours of learning experience was difficult and confusing, and where do I click where to get what? After that, beautifully intuitive. Not Zoom is more intuitive, but XSplit is quite intuitive. You click on the objects you want, and you can position them. You can crop. You can enlarge, and so you have total flexibility on what the screen presentations look like. So it's very convenient to use. You don't do any of that on the fly while you're talking. You have your scene set up ahead of time, and you just click by scene, by scene, by scene, and then every image and function is brought up automatically.
Yeah.
No, I want to thank you, Bill. That was a great presentation that I can use in work, and it's applicable to. It was fantastic. Thank you very much.
Yeah. Yeah, I also appreciate that you brought all these ideas together and give us hints. So that's very valuable. Also, if you say that's the program you want to use, and
Ulrich, we have 3 meetings. One is the German FIG meeting. The other is the Forth-2020, and there is a guy driving in a car. So this is the first time in Zoom we have a mobile.
Yeah,
a mobile member.
Hi, Don. Yeah, that's great. That's great.
Hi, Don. Take care.
Hey, gang, this is pretty cool.
Drive safe.
Drive safe. Pablo is very concerned, Don, with you.
Yeah, sure. Okay, you're not driving yourself. That's good. Very nice. So, yeah. Are there any additional questions to Bill or remarks or some other guys that have experience with other software?
And unfortunately, I have to say goodbye because I have conduct another Zoom meeting in 1 hour, so I have to go do setup. So thank you very much.
Sure, you're welcome.
Thanks, Bill. Fantastic. Thank you.
Thank you very much again.
Thank you.
Thanks.
Thank you very much.
Bye.
By the way, Don, I just have to warn you, you're going to get a speeding ticket because they'll figure out that you're Zooming while you're driving.
I'm not driving.
He's not driving on its own, so he's just a passenger.
He's a passenger.
Hey, he's on the wrong side of the car. Here in Australia, we're on that side.
Yeah, that's United States, so they have the steering wheel on the left.
But Peter, I did enjoy the Zoom pun.
Mm-hmm. So, right. So shall we continue?
Yeah, Ulrich. Okay.
I think so. And So
okay. Sorry.
Yeah, I can introduce myself.
I need to introduce Ulrich. Sorry, guys. Ulrich, your talk is about tutorial forced data structures, enumeration types.
Exactly. So let's see how I get there. Yeah, here we go. I hope you see the slides.
Yes.
Yeah. Okay. Wonderful. Yeah, we thought that it's nice to have a tutorial talk where we present ideas that are, well, something like common knowledge, but are not actually written somewhere. And so it might be difficult for people new to Forth to actually approach them. And I've been talking about data structure for a couple of times already, looking at records and arrays. And well, if you look at other programming languages, they also have enumeration types. So we will look into what this actually is. There's one slide I repeat again, but we'll go on it very shortly. And then we will look at how to define Forth enumeration types and how do we do this. And yeah, you can define words, which is fine, and we will do that. But also, I found it, if I program Forth, that for short sequences, I also often use just the sequence of words. So swap drop, for example, instead of nip. And if you have an optimizing compiler, then it makes actually no difference if you use one or the other. So I'm very fond of also using Forth phrases. And so it's like in your mother's language that you have certain sequences of words that have a specific meaning, and you just know them, and you don't invent a new name for this phrase. So and then, of course, we can give these phrases names and then get a nicer syntax. And also we can use the technique that we have been looking at also to define bits in a word for accessing specific parts of an IO port or for or other things, for example. And then we come to a conclusion. So often if you talk to Forth about Forth with people that don't know Forth or start to learn Forth, then often the question is raised, Forth does not have feature X. And then why is this so? And then the seasoned Forther says, well, you define X on your own depending on the application, and there's so many different application needs that a general solution is no good. And X might be structs, records, it could be arrays, it could be objects, it could be enumerations, which we look into today, or it could be additional control structure like a case statement. And of course, some Forth systems have a case statement, but that's one of the early exercises that you go and define your own case statement. Yeah, and yeah, so we look into different areas here and see how do you do the definition of X in your system. And I hope I can bring over the idea, and you take your system and do whatever is necessary there. So an enumeration type is actually something where you give a name to a value. Yeah, say you want to talk about days of the week. Yeah, then you have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And but inside the program, you might not want to store the strings, but you want to store just an index. So Monday would be 0, for example, and Tuesday 1, and so on. And you do this because if you don't, if you have these kinds of magic numbers maybe, or numbers, you don't remember them all. And so it's better to give them a name. And also, it might be that the number of distinct values or the distinct values themselves actually will change. And so you would easily add a new value, give it a new name, and so on. So for example, if you're programming a state machine, then you have a collection of states and you enumerate them also 0, 1, 2, 3, or what have you. And you typically give them names like idle or waiting or accepting and things like that. And it could also be that you want to write portable programs. So maybe you have IO port addresses and you just want to give names so that you just have to change the mapping from names to concrete values in order to port your programs. Yeah. And what you normally do in Forth or in other programming language, if they don't have enumeration types built in, you just use constants. And so let's look at an example. So maybe you want to have a way to name colors in some output. Yeah, and then what you can do, you can go ahead and say 0 constant black, 1 constant red, and so on. And then you would give names to the appropriate constants. And then if you want to output something, then you can test for the appropriate values. So this is a case statement in the end that distinguishes and discriminates with respect to the color C that we have here. And here just outputs a text. Yeah, of course, if you use escape sequences or have some means on your system or your computer to have colored output, you maybe want to switch here appropriately to output the appropriate colors. Anyway, so that's I would say the easiest way to do that, and it has some drawbacks. So maybe you want to rearrange these, and you want to change the order, and it could be that you have some typos in there. Maybe you have the constant 3 twice or whatever. So the idea is to use some technique that allows you to make it easier to not do any typos. Yeah, and the idea is, well, in Forth we have the principle of ICE, interpret, compile, execute, which means we can do calculations while we are compiling a program, and that's actually great. So instead of naming the constants or giving the exact values for defining the constants, we let the autointerpreter do the appropriate calculation. So we put a 0 on the stack, and then we always do dup constant and give it the name, and then we say 1 plus, and we every line looks the same, so there is no chance in doing any typos here that would do conflicting numbering of the values that we define. And so, yeah, that's from my point of view, that's actually an improvement. We can do this, and if we want to add a new value, we just copy one line, change the name, and that's it. Yeah, and then we can just go on, and the autointerpreter does all the appropriate calculation. So that's nice. And well, one drawback is somehow the calculation is here and also here, so it's in different parts. And so maybe a better way to do this is use a sequence that works better, so that all the calculation is in one place. So instead of dup constant x 1 plus, we say dup 1 plus swap and then constant x. So all the calculation is done in front of the line before we define constant x. So that means we go like this. We say 0 and then dup 1 plus swap constant, and it has the same advantage that you can just copy the lines if you want to add a new value, or you just rearrange the lines. if you want a different order. So that's actually nice. And so something like this is what I call a fourth phrase. And I like these, and others want to give names to them, like over plus swap. We once had a presentation of some program, and it had over plus swap in it, and then people just jumped out of the seats and said, well, that's bounds, call it bounds. And yeah, so if you use too many phrases, then this might be a sign of bad factoring, and it would be good to combine them to a new name. But yeah, that's probably a process that is evolving over time. You have to find this out. Okay, and then we can give it a name. And if you ask a mathematician what would be a good name for this, then he says, well, we can call it iota, which is the Greek letter iota. Means very small thing, and there are programming languages that use this for enumeration types. You can also call this enum or whatever you want. So iota is probably a way to do this. And so just what we have, and I think I made a mistake here. Dup1 plus swap must this be. So at this point, it must be 1 plus. It must be dup1 plus swap. So I'm sorry about having that error in there. This must be dup1 plus swap, because we just replace the phrase that we have with a word that we define. Yeah, and then we have 0, iota, and so on and so on, with the same benefit that we can change the lines and we can add new lines if we want to. And of course, we can go ahead, and here we go. If we have Unicode for it, we can use the letter iota as our fourth word name, and then you can just write things like this if you want to. Yeah, I don't know if iota on the small hook is appropriate, but it might be a worthwhile thing to do. And here you see the correct definition of iota. Right. So yeah, what you can do is, of course, maybe the constant is not so nice. You want to combine this to a new word, and so you could define a defining word enum, which takes the name of the new value and also yeah, the appropriate value from the stack. So you could define enum as being iota constant. And if you do so, then you can just put a 0 on it, and then enum black, enum red, and so on to have the same effect. Maybe you say, okay, this dup1 plus swap is not so nice, and we name enum, we define just enum, and you do it like dup constant 1 plus, having this separated, but it's then in only in the definition of enum. And that might be appropriate. This is exactly the way that SwiftForce defines the word enum. Yeah. Okay. Right. And then you can go ahead and if you have iota and you don't have it combined with constant as in enum, it might be reasonable as a factor to use this, because if you get the value, then you could do some more calculations on it. So remember, iota gives you 0, 1, 2, 3, whenever you call it again with the appropriate parameter. So if you take the value and you take a 1 bit and shift it appropriate to the left and define a constant, you actually go ahead and name the bits in a word. So you start with 0 on the stack as before, and you drop the value after at the end. And with bit, you define the bit 0 at magnitude 1. Then you define bit 1, which corresponds to 2. Bit 2 corresponds to 4. Bit 3 corresponds to 8, like we can see here. So maybe you have a 32-bit word. And so it just names this bit. Yeah. And then you can use these bits in something like status fetch bit 2 OR to check for whether or not to set, exactly, to set the bit 2 in your status fetch bit 2 OR status store to set this, or you might with invert AND reset a bit, and of course you might want to give these phrases again names, and of course you wouldn't call the bits bit 0, bit 1, bit 2, but RX ready, TX ready, or buffer overflow bit to test. So the idea of having iota is actually universal. You can just do that and use iota also. Use iota also for defining bits, which is very similar to enums. So in Forth, you define just the essential of what's going on, and you can extend it in things that other programming language cannot do. So, for example, Golang has iota for defining enums, but it can't do bit field definitions as we see in this slide. So that concludes my talk for today. We can have Forth enumeration types if we want to. We can give names to values either by doing this explicitly or with phrases, or implicitly if we have some iota word that does the calculation, or some enum word that does the definition as well, and is a defining word for defining enumeration values. So that's what it is. In the sequence of talks, tutorial talks, we have some things still open. So we have another check mark that we can do on enumeration types. And there will be 2 additional talks, at least, that deal with automatically resizing arrays and the RAM-ROM distinction that we encounter in some systems, and their role on arrays, and also related to structs. We can have fields that contain execution tokens, and then we can build objects from these structs with execution tokens, or we can have arrays of execution tokens and do indexed indirect call of functions, and then we can implement objects. But that's another story. Thank you very much for your interest, and I'm open for very short questions. Please.
Thank you, Ulrich.
That was fantastic. I like the idea of enums.
Mm-hmm. Yeah, right. So I find it's very reasonable to give names to things, and not just use magic numbers all over the place. And so, yeah, so that's actually the idea.
How about if you have an enum counter, and then you can create a defining word that goes and grabs the counter and creates a constant in the dictionary?
Mm-hmm. Yeah.
A comment from Christian.
Yeah.
Beginners love hearing about data structure because we don't normally know how to use them properly.
Mm-hmm.
And we don't know the basics of languages in general. We don't know what is enumeration, structure, and all that stuff.
Mm-hmm.
So good work. It will help at least beginners.
Can I?
Yeah, you don't know what you don't know, right?
Can I just ask a quick question, Ollie?
Sure.
This word iota, which I think is really neat. How would you describe what it is doing in one line?
What it's doing? It calculates the next value, providing the old one.
Okay. Yeah.
Yeah.
So I think if you can express it in one line, it's maybe worth being included into Forth, if it's a useful factor of all sorts of other things.
Yeah. Which needs to be found out. I think at least I gave 2 usages, like we can use it for defining enums and also for bit fields. So I think that's actually
it's a start.
Yeah, and if it turns out to be more useful, then it might play the same role as bounds that hasn't been standardized, but everyone knows about what it is.
Ulrich, eine ganz kurze Unterbrechung. Die Gruppe wartet auf deinen Vortrag. Hat der schon begonnen?
Nee, der würde jetzt losgehen. 16 Uhr. That's Martin is asking whether the next talk will start.
Ich habe jetzt deine Antwort nicht verstanden. Da muss ich erst hier irgendwie die anderen leiser kriegen. Da weiß ich nicht wie.
Okay.
Antworte mir jetzt nochmal.
Ja, es geht hier gleich los. Yeah, we will start in a moment, and let's see. I will switch over. So the great challenge is actually to synchronize both conferences here, and so we said 3 o'clock on universal time is the time where the next talk will start, which is just about now. And I'm trying to share screens on both of the conferences. So let's see if this works. So this would be the screen, and you see now the Forth-Tagung in the Zoom meeting. And let's see if I can, someone needs to make me presenter in the big blue button, please. So that I can share also my screen there. So. Maybe I can be here. I can manage presentations. No. Share your screen. Okay, it works. And let's see. We do this. And hopefully in both of the conferences, you can see me. And here we have the infinite mirror again. And so please let me know if you see the project ForthWorks in both conferences.
Working here.
Okay.
Okay.
Forth-Tagung?
See it here.
Okay, wonderful. Okay, so that was bad. Here we go again. So I want to say ausblenden. No, that's okay. It doesn't work. Then we have to live with that. Anyway, here we go. Okay. So same question again. Can both conferences see the project ForthWorks slide?
Yes.
Yes.
Okay, great. This is actually a thing that evolved from the Forth2020 meetings. We had discussions about libraries somewhere in March or February. And then a couple of guys, especially Ouwerkerk and Martin Bitter, thought, yeah, maybe we can do something to better share our ideas and to exchange programs. And so after a couple of while, they asked Thomas Goeppels and myself to join this, and later on Gerald Hoekstra has joined us, and Albert Niehoff is with us discussing. And we thought about a name, had a working name in between, and now the project is called the Project ForthWorks after lots of discussions that we do. And the key idea is that we really want to work along with the other Forthers to improve our techniques, to learn from each other. And we try to unify programming in Forth for a very long time. And actually, it turns out, well, this catches on only in a certain area. So, and there's this Forth saying, if you know one Forth, you know one Forth. Last month, we had the discussion and said, okay, yeah, Forth is probably a personal language. Everyone can easily tweak it to its own needs. And that's an issue. And we say, okay, no, let's do it in another way then. How can we work together in another way? Let's embrace the difference. And then the project ForthWorks actually evolved from that. So what is the project about? I want to talk, what is our aim? What do we want to achieve? You got a little idea of what it is already. Then the project has already a web page, and it's intended to be a collaboration project where people join us and also contribute, and we will see how this works. So I will show a little bit of the project pages and describing what we intend. And the main term that we use is idea. So what we want to describe in the project is ideas. Say, how is a certain communication protocol working? Or how do you do JPEG encoding? And not so much the implementation, because if you know 1/4, you know 1/4, but more getting into the idea so that people can understand this, giving some general implementation, of course, but then also open up for all the many different implementations that might arise. And how an idea is best described, we made lots of discussions on what we think is appropriate. I will talk about that. And then we have a bunch of ideas already described this way, and I will just give you a short glimpse of what you can see already. And then, of course, we want to have many more Forth ideas described, and ask you to contribute with your ideas. And we will talk about how to do that. That concludes then my talk. So let's see. The idea is we have a great knowledge within the Forth community, and everyone is very talented and knows in specific areas much more than all the others. So we really want to gather all this knowledge and spread ideas. And if you have certain implementation algorithms, then explain people how to do that. We want to do this with communication protocols, but also simple applications. I mean, one of my favorite is the Tetris for terminals application that's always in my pocket. So if I have some spare time in the Forth system, I can go ahead and have a good play. Also hardware drivers or what have you, development tools. And the approach that we have is first describe the idea, and tell the people what is important about it, what is the trick behind it, and how things are connected. Then give an algorithm in pseudocode, which might still be usable for a C programmer or a JavaScript programmer. And then in the next step, use a dialect which we call generic Forth. That's not a programming language for actually having a Forth system, but it's what we think is colloquially known Forth, common Forth, like bounds, for example. Everyone knows about that. And generic Forth is a very simple Forth, very straightforward, so that if you write a program in that, people can easily understand what's going on. And also your example should express the idea in an algorithmic way and not so be too clever to make it not understandable. And then, of course, an idea has lots of background information. And so it's very nice for you to collect the information to describe what things can go wrong and so on. In the Forth-2020 meeting, we had just had Bill Ragsdale talking about what do you need to do to make a good Zoom presentation. And so he gathered all the information that is necessary from lighting, from programs that you want to do. And this is also something that we might very well exchange. And so even that could be an idea where one person can explain to the others what's going on. So, and then of course, you might want to have an implementation for your specific system. And we embrace the difference between all the four systems by giving several implementations. So whoever wants to contribute something with his specific system, he's invited to provide implementation for his system. So, and luckily, if a popular system is the one you use, then you will find maybe a Make-RISP implementation very easily, or a no-faults implementation, or an ESP32 implementation of the general idea. And then you get the complete picture. Yeah, you get the description of the idea. You understand how the program works in general using pseudocode and generic force. You get all the background information, and you get a specific implementation for the system that you want to use, that you might want you might use as it is, or you go ahead and says, I don't like this. I optimize the source code for the system because I can program much better than all the others. And then you're asked to contribute, of course, to your optimization. Yeah. Also, it could be that you have some old projects where you never be able to finish it. So you can at least start describing the idea. Don't provide a specific implementation for a certain system, but just provide and contribute what you have. And then we can go ahead and maybe someone picks over. So it's not actually that we want to have ownership of ideas, but we want to have a collaboration. So if you have an idea and or see an idea and you know how to improve it, then of course it's reasonable that you contribute and provide the thing. One word, we have other sites that do library sharing, like the Forth.net or the Forth Scientific Library Project or whatever. It's a different approach because we don't put the algorithm and the programs in the center of our focus, of our view, but the idea. So it's more that we have a textbook that we write where you describe things. Okay, and yeah, so that's actually the aim of the project. We have many different force systems that are more or less incompatible, and you have to be expert in several of them to actually port programs back and forth, or be a standard programmer. Then you can do this with standard programs. But we really want to share ideas and have specific implementations for the small force systems, and also for larger force systems or for the fat force systems. So everything is included. We embrace all systems and see how we can go ahead. So there's a project webpage called project forthworks.github.io. So all the data is currently hosted at GitHub, and there's also a GitHub repository that you can do, which summarizes, the webpage summarizes what I've been talking about here right now. So you get the idea, and you can also go ahead and browse to specific ideas that we've described. So for example, in the communication protocol section, there is a section on I2C, and which explains the idea, which explains how the protocol works, and gives pseudocode and generic force implementation and with bit banging, and then also specific implementations on the GD32 or the MSP430. And where we have other force here, you can just go ahead and make a contribution, say, okay, I've read the idea, I do it in a similar way, so I can contribute my implementation there as well for others to share. Right. Yeah, that's what I already talked about. Yeah, we have a template that describes this. So if you say, okay, I want to start to also describe an idea, then you can follow the template, and it goes ahead and gives you some structure. Yeah, and you see it here. So describe the problem, explain how to use it, then yeah, give an explanation of the algorithm, pseudocode, generic force, so the background information. And then if you have a preferred force system, then just go ahead and provide also a specific implementation there. Right. And so what ideas do we already have? We've seen I2C. There's SPI as communication protocol, but then we also started doing data structures. I have in mind a sequence of ongoing, growing data structure ideas, so described. We currently have a primitive circular buffer with just one pointer. Then, of course, there could be a circular buffer with 2 pointers and so on. We have a bit array where we are able to address individual bits in an array. That's on the data structure part. And then we have algorithms, random generators, and Pilipop that we can show. So please have a look at these ideas so you get an idea of how to describe these things. And then we thought there's also the necessity for system software. So the dump utility started out as being a very simple idea. We can also see this as an example how we think things and ideas are best explained. And we have a growing number of disassemblers for different things. Yeah, you best start with the template, and that's also the idea. What could you in principle contribute? Yeah, maybe you have string handling features, a string stack, data structures. You have more communication protocols for one wire, for USB, or different memory interfaces. You can access smart paper, e-paper displays, or whatever, temperature sensors, or whatever. Then, yeah, why not go ahead and describe how to do it so that others can actually learn from it. Yeah, or other programmer tools like a serial terminal with maybe intelligent additional functionality. And then we also have the applications. We talked about games as the motor for getting into Forth earlier this day. We talked about robotics in earlier meetings or data loggers or whatever applications where you say, okay, that's something, it's good educational to explain how to do them and then provide the appropriate general and specific implementation. Right. So if you say, well, then I think I have something, and how can I actually contribute? Yeah, then yeah, maybe you go with the template. Have a look at what we say. So it's not just the headlines, but also describes a little bit what you might want to put in there. You can read the dump example to see how things can be done in the real way. And then you might look at some other examples, not focusing on the idea itself, but on the structure that you use. Yeah? And to make it easy, if you have something, then get in contact with us. Email addresses follow on the last slide. Yeah, and just send us our code in the structure that we have following the template. And then we will go into discussion with you and see that it will make it work in there. If you say, yeah, I want to get more close to the group and also contribute completely on my own, then you would become a member of the project, the ForthWorks organization, how it's called in GitHub terminology. And then you have to have some knowledge on Git, the version control system, and then you can clone the environment, do your additions, and then contribute appropriately. Right. So that brings me to my conclusion. So in our last very great talk with Charles Moore, it became clear Forth is a personal development environment. And that's the reason why we have many incompatible dialects. Yeah? So if you start explaining some technique, it's very normal that 2 or 3 other guys stand up and say, no, in my system, I do it this way. And we don't want to have this as something that separates us, but something that unites us. And so we embrace that difference. And we try to standardize Forth systems, and that's good for what it's worth. If you have standard systems, then you can port programs back and forth. So that's nice. But if you don't, then you have to see that it's much more difficult to port programs. And so it's much better to exchange ideas there. And so, yeah, that's our way. We want to accept the difference and embrace them and make the best out of it. So we should not hesitate to share our ideas because all the others have incompatible systems or that behave in a different way. Let's share our ideas, explain them to the others, also in the spirit of this is some kind of Forth philosophy and technology conservation that we do. And we think our idea with this project ForthWorks is a try to get something that might also attract certain kind of younger people that really want to understand, that just are not satisfied with clickety-click and collecting components from different sites, and then once the program compiles, they're happy, but really want to understand what's going on, and we can give them a way to also do that. So I would say go forth and let's contribute to this project. Right. So here are the addresses whom you might want to contact if you want to contribute to the project. That's it for the presentation, and I hope we have a good question and answer discussion, which we need to do in separate because one conference cannot hear the questions from the other, but I will try to collect them from both sides, and maybe in the Forth-Tagung, Gerald can just collect them and then we do them. So that's all new as well, how we do this with two conferences in the end, and how we do questions from both sides. But I'm open for questions, and I have microphone open on both conferences, so I could hear both, but you can't. Any comments, questions?
Oh, Christian is there for sure. When I hear the sentence, if you know one Forth, you know one Forth, it makes me feel like saying, if you know Latin and Greek, it's useless because it created French, Spanish, Portuguese, and Italian. Now, languages evolve.
Yeah, so that's so Christian says, yeah, that's natural. Languages evolve like the natural languages, and and it's worthwhile. And that's exactly our opinion. We don't want anyone to stop finding and exploring new ideas and tweaking his system. That's valuable, and that's what we've been done for a long time. But it also limits sharing code, which we accept and say, no, then let's share ideas. And yeah, and then everyone can have its dialect, and that's fine. Right. So maybe a question from the Forth-Tagung, or anyone has a question there? No, at least I can't hear. Please say something. Maybe I can't just hear you, Martin. I can't hear you. Why is that? Let's see. Okay. Now, yeah. Please, if you have Forth-Tagung has a question, then please just go ahead. Oh, yeah, Anton. Or okay, so it doesn't seem to be that there's a question in Forth-Tagung, but maybe in Forth2020. Yeah, that is Ralph Lundwall. You have to unmute, and then we get this. Okay, Ralph, we can't hear you in the moment. For a moment, your mic was open, but now it's closed again. So if you want to ask the question, then please unmute. Yeah, Gerald. Yeah. Yeah, okay, right. So, yeah, that's right. There is a question that actually came in the chat on Twitch that Gerald just read to me and said, well, this project looks like Rosetta for Forth. And I would say, yes, that's what it is. During the discussion that we had, Rosetta came up again and again as being some good platform and some good idea to do this as well. And yeah, so in some sense, it's like this. Okay, are there any questions in either of the channels? Yeah, it's Gerald. Yeah, so what Gerald's question is, how do the other library sites actually would work with the project? Can you also develop on the other sites and then link or whatever? And the idea is yes. Our focus is mainly on the description. So if you look at the Forth.net, then you get the names of libraries and you have the package manager to get this. And maybe you get a package description of what's going on, but it's not in this extensive structure that you explain the ideas of what's going on, what the algorithm that is behind that, actually how that works, or links to others. You can do this, of course, in the README, but the idea is that you use the project ForthWorks for this, and then you link to wherever you can get this. So one of the specific implementation could also be, yeah, just go ahead and use the Forth.net package manager to install that. That's completely fine. Or it could also be just some GitHub repository that you link, or some other site. Maybe you want to contribute parts of the larger project, then of course you would just make a reference to it. So I actually see this hand in hand, and my intention is for the data structures, I also want to provide libraries on the Forth.net to actually, yeah, so that you can go ahead and load the appropriate implementation by the package manager, or just downloading the zip file there.
Ulrich, may I add something? We could also add the library manager.
Yeah. So Willem is saying something. Sorry, Willem.
Okay, we could also share different library managers there. We also already talked about that.
Yeah. So Willem says we can also share different library manager and be open on that part. And that's actually what we want. So I think this could really extend to all the others, and it's not to give up anyway in any site that you actually use, but as our focus is on exchanging the ideas, this might be a good way to start to see this, and then you have the references to all the other library or implementation or GitHub or whatever, and you can use them. Right, I think so. So Gerald just told me that's it on the ForthGesellschaft side. So I would say thank you very much for listening to my talk. And it's an experiment whether we can do a talk and 2 conferences at the same time. I'm always open for experiments, and I learned a lot about synchronicity and things like this. So thank you very much, and I will join Forth-Tagung also in just a moment, and we keep there. Thank you, and so okay. Right. So, yeah. Any other questions regarding the project? Any comments? Willem, maybe? Did I miss anything to explain, or was this fine?
Only one small thing. Adding examples.
Yeah, which is certainly what you want to explain the idea more, and you have the algorithm, then you can show how to use it and give examples. Is that what you mean?
Yes.
Yeah.
But that's it.
All right. So let's see how
Question from Christian.
Yeah.
Could you describe the process of contributing?
Yeah. Please have a look at the webpage. And I think we will post the details in the chat, the forthworks.github.io, and then you read the project description again. To contribute, it's best to make yourself familiar of how the structure of an idea actually looks like, which is also described on the webpage again. I think I explained a little bit about that. And then you can just take the template as a starting point, as your blueprint, and then fill in the details of your idea if you want to. And then you just send Willem, me, or Jeroen in an email, and we will incorporate that. So that's the process.
Yes, and if you're not familiar with GitHub, we have a small start page for it. The Git cheat sheet. How do we call it at the moment?
Simple guide, something.
Simple guide, yes. Git simple guide.
Yeah. So we did a lot of name changes lately, and so we are still in the process of being consistent on the naming. Yeah, the simple guide to Git. Git guide, I think that was the nice thing.
Yeah.
Okay, so if there are no further questions, I would say we would continue with our meeting. And that would mean our next speaker is CH Ting, talking about ESP32 Forth_85. And we learn about the much cleaner and meaner version of how to do ESP32 Forth. Dr. Ting, are you ready to do this and do your presentation?
Yeah, let me just grab screen.
Sure.
And do the sharing. Okay. I hope you have seen my screen.
Yes.
Okay, yeah.
Excellent.
All right. So this is the ESP32 Forth version 85. And just briefly, Chen Li helped me move the eForth into C++, and we put it into the window and call it Win eForth or WineForth. And then he moved this implementation based on C++ to ESP32. And it became ESP32 Forth82. And this version is further streamlined, and the GUI is a little bit improved, and we have version 85.
And this is basically a very simple implementation of the Forth virtual machine in C++. So we have, and this Forth virtual machine has a dictionary. It has all the Forth words. And we have an auto interpreter, we have an inner interpreter, a return stack, a parameter stack, a terminal. So that's basically a very simple Forth virtual machine. And the outer interpreter, the inner interpreter are all coded in C++. And all 120 primitives are also coded in C++. And the application words that you add to this system will all be in colon words. And so this dictionary is kind of conventional with name field, the link field, name field, code field, and parameter field. So it should be a very familiar to most of the Forth programmer who's familiar with the Fig-Forth model and E-Forth model. So the this ESP32 Forth, the main interface is the Arduino serial monitor. And we also put in a web page so that you can control and program ESP32 remotely through a web page. So what we did was there is a SPI FS file system in the ESP32. So we would like the applications, application programs written in Forth to be stored in this SPI FS file. And this file is loaded on boot so that you can do a turnkey system. So the kernel is all in C++, and the application are all in colon words, and all the file will be loaded when the system is booted. And here in this short presentation, I would only show you the extremely tight outer interpreter that is Forth itself. So this is the entirety of the Forth interpreter. The Forth outer interpreter doesn't have to be very complicated. It just the parser gets out that string or idiom, and then we would look this idiom from the dictionary. If we find a word, and this word will be executed if we are not in compile mode, or if the word is immediate. Otherwise, we will compile it, okay? So we'll run it if it is an immediate word, even if it's in the compile mode. And if the word is not in the dictionary, we try to convert into a number. And if the number conversion is successful, the number will be compiled to as a literal if in the compiling mode. And if we are not in the compiling mode, the number is just pushed on the stack. So this is what the outer interpreter is, or Forth. And it can be written very easily in any other languages. So I would think if we do this all in C++, the entire Forth system becomes quite simple. And then we have all the primitives. All the primitives are just C++ or C code, and they can be implemented quite easily. And all 120 primitives will implement in this system. So they are all available on boot. So we have the principal interface is the Arduino serial monitor. When you boot up and type words, you will see about 120 primitives and close to 150 application words, basically to run the robot. And one thing I would like to mention is that there's an input box in the Arduino serial monitor. It looks like you can only type in one line at a time, but this input box can accept a huge file, okay? So if you just copy a big file and paste into this small window and then hit return, the entire file could be compiled. So this makes programming very easy because you write your code in a text file and then copy and paste the file into this input window, hit return, and it's just compiled. So I think we don't need a very complicated supporting system to develop significant applications. But we also provide a web page interface. When the ESP boots up, it would look up on the local network and report the ID it's being assigned. If you open up a web page, here I'm using Chrome, and then just type in this ID, hit return, and you will get a web page. And this web page has a big output box and a smaller input box. You can type in words in this input box, hit return, and gets executed, and it will be the result will be reported in the output box. And so this input box can also accept large text file, and you can cut and paste a big file into this window, hit return, and everything will be compiled to the system. So this is a very useful interface to develop significant applications. And but the system is extremely simple. And here in the conclusion, the ESP32S Dev Kit, that's I think that's what you'll get on Amazon for about $10. It is by far the most powerful and the cheapest microcontroller kit, and especially it is Wi-Fi ready. And the ESP32 Forth85 is the smallest and the cleanest Forth for this kit. And the file is only about 14 kilobytes long, and it is less than 600 lines. So, and with this one, you get the virtual Forth machine, and you have the web page interface, and also many other tools available for the ESP32 kit. So it is very suitable for robotics and turnkey applications on ESP32. And this file, the Arduino file, which is ESP32 Forth_85.ino. I have the link was already put into the chat. So if you scroll up the chat, you will see the link, and you can click the link and get the INO file, which you can upload, or you can compile and upload on your Arduino kit. And so this is what I have right now. Okay, hope that you guys, if you have Arduino ESP32 kit, do take a look, see if you can get it to work on your kit. And it is very simple, and I think I hope it is a model, a new model of eForth system that you can move around very easily, because the code is very tight. Okay, let me just exit and open for any question. Thank you very much.
Thank you very much. Thanks, Ting. So are there any questions to Ting, to the new way to do that?
I think Christian will have a question. I'm a big user of ESP32 Forth. How does this one differ from the actual one on Forth2020?
Yeah, interesting. It's totally different. I'm sorry, Peter. I'm really sorry, because I haven't looked the ESP32 version 7.705. I only looked it up last night, and I couldn't recognize it. Okay, it is totally different from the ESP Forth62 that I gave to Peter and Brad. So it's being extended very significantly, and so it is not recognizable. But the reason I did this was that I was very embarrassed looking at the version 6.2. It was a very poor implementation. And now that I have implemented the eForth system for the JavaScript and for Java itself, and also C++, I thought that I knew a much better way of doing the eForth. And it is a much better way. It's much simpler. I think it is very tight in its memory footprint. So I would hope that you guys will take a look and see what you can do with it. Okay.
No, you can be sure.
Because it is simple, so you can further enhance it in any direction that you want. I have a question about the implementation. You see a lot of TOS standing there. Is that macro, or is it a special in C++? It is basically in my original implementation, the version 6.2. I really did try to move the eForth model in C. Okay, and C doesn't have much support in building the Forth dictionary, which has a variable length name field and the variable length parameter field, or even code field. So I was trying to build this Forth system based on vanilla C. But Chen showed me that in C++, you have a lot more tools to build very flexible data structures as required by Forth. And so he showed me how to do it. And we just moved the eForth model into the C++ and use many of the facilities to do very flexible data structures in the dictionary. So it is a much cleaner implementation. So I would really like guys to take a look and see what you can do. The link is in the chat. So download it and run it on your Arduino system and see what you think. Okay.
Okay, thank you. Any additional questions?
Christian again. I think we moved away from the eForth concept with the 120 primitives written in C. Is this right?
Yeah, that's right. That's right. It's what I wanted to actually in the next week, in the fourth day, I would talk about Forth without Forth, because all the existing Forth are basically written in Forth. Okay, and we in this year when I'm testing many other languages and operating systems, I found that Forth is not that difficult to write if you have a good operating system and the programming language behind it. And actually, Forth becomes much simpler if you write it in the native compiler. So I would say that that's Forth without Forth. Okay. And the Forth without Forth makes Forth even simpler. Okay. So that's a topic next week.
Thank you.
You're welcome. Thank you.
Thanks. Any additional questions? All right. Then thank you very much, Ting, again. And so next week, there will be also the fourth day of the San Francisco or the Silicon Valley Forth interest group. So it's probably also interesting to join there to see what will be talking about there next week, and Bill and others. Great. We proceed in our schedule. And so we have the Fignition party Fignition is a small board, a microcontroller board, computer board, built out of contemporary parts, so that everyone can assemble. And so I do not know much more about that, but Ashley does. And so I would kindly ask you to talk about the Fignition and the Forth that runs on it. Ashley, are you prepared?
Yep, I'm prepared. So I actually pre-recorded a talk, as I usually do, and it was recorded before I knew that Julian was going to be here. So just think of it as a quick demo. You know, these are Fignition. Whoops, that's not going to show up with my background.
Hold it in front of your body. Yeah, that works.
Little Fignition boards. And so I was just going to talk about a demo of some application that I made for it. And I think Julian is going to talk afterward about some of the more detailed.
Yeah, Julian actually left already, so probably next month, but that doesn't matter.
Okay. Let's see, I will share my whole screen, I guess, and just play the video because I don't see an upload. Oh, there is an upload. Just 1 second, sorry.
Yeah, that works.
Okay, so I wanted to talk about an old project of mine. This is from a decade ago almost, 2012, to write a turtle graphics for this little Fignition board. That was a pretty fun little project, and I learned a bit while doing it. This is the Fignition itself. So it's a project by Julian Skidmore. I think he's in the group. Maybe he'll give a talk on it at some point. But briefly, it's this little board. It runs FigForth. It's an Atmega 168, little 20 megahertz crystal, 8K of SRAM and 384K of flash. It generates audio, can generate audio, and generates a composite video signal. So you can just plug this into a TV or a composite to HDMI adapter, and you're good to go. It has this 8-button keypad for input. A little bit of a strange input system, but it's kind of fun. This is how I actually implemented the first instance of this turtle graphics, is just on this keypad. So single presses of buttons give you arrows and space, and I think backspace, and then holding down multiple at a time, you can get the whole alphanumeric set, which is pretty cool. So of course you get a FigForth prompt, and you can just type there directly. It also has a flash block editor that lets you edit 500 character, 25 by 20 character blocks in Flash and store them there permanently. I should also mention though that the keypad, for one, there's a separate module which I've never used, but it adds a PS2 interface for this, a keyboard interface. You can use a regular keyboard. And you also can transfer text files from a host PC to the device using AVRDude. It transfers to EEPROM, and then there's some commands to transfer the EEPROM to Flash. But it's very cool. I paid £20 for this. I think it's slightly more now, but you basically get this printed circuit board and all of the components, and it's up to you to solder it together. And it's just like really, satisfying to get this and solder it together, plug it in, boot it, and you get a FigForth prompt right off the bat. It's pretty cool. So I heard that it had a 160 by 160 graphics mode, and I wanted to make a turtle graphics implementation for it. So here's the block editor. Here's some of the turtle graphics demos. And so you can see, obviously, it had the character cell video mode, but this is the 160 by 160 bitmapped graphics mode. And so, doing all of the kind of normal things that you might have done with Logo on an old microcomputer in the 80s. Pretty fun. So here's the code for it. And, it's very simple. There's really not that much interesting. There's one piece that's kind of interesting, and that's what I'll talk a little bit about. But, turtle graphics, of course, it used to be that there's a little turtle marching around on the screen leaving trails. Here we don't actually draw the turtle, but it has an X and Y coordinate and a current heading angle. And for performance, I go ahead and keep the delta X, delta Y for whatever given heading you have. So we can just do simple arithmetic to update its position. You can set the heading directly, just an angle, and we'll store that away, and we'll compute the delta x, delta y with a sign word. So one interesting thing is the Fignition doesn't have floating point math, for one, and it doesn't have any trig words like this. So this is a word that we wrote ourselves, and this is one of the most interesting, I guess, little bits of this thing. Worth talking about at least. And there is only sine, so to get cosine, we just offset the angle and call sine again. You can also turn by a relative amount. So you just say turn, give it an angle, and it'll add that to the existing angle and set the heading. That's usually what you do, actually. And you can have the turtle move forward. So here, you give it a distance to move forward, and it just marches along inside of a do loop, updating the x and y, and drawing a pixel at that position. And we'll get into some of the poor performance of this particular implementation in a moment. But that's the basic idea. In a normal turtle graphics, there's a pin up, pin down, to decide whether it's going to draw or not. Instead here, we just have forward, which always draws, and then jump, which does the same thing, moves the turtle, but it doesn't draw. So it just updates the x and y. Then just a few extra words is all to start the whole thing, get into the right video mode, reset the position and heading of the turtle, and then end just waits for a key and switches video modes back so you can type again. And clear just fills the bitmap buffer with zeros. That's it. That was the whole implementation. And now to use it, here's some examples. First, this sign word though is the interesting thing. So here we're just plotting across the whole screen. It's a 160 pixel wide screen, and just calling sine for each of these increments. And you can see that it ends up plotting a pretty sparse sine wave. The idea is that this sine word, it actually doesn't take angles, or it doesn't take degrees. It doesn't take radians. It takes angles in 1/60th of a circle at a time. So I'll pick something smaller just to reduce the size of the table. And 60 is still evenly divisible by a lot of things, which makes it still convenient for turtle graphics. Iterating through just those 60 possible angles, for each of those, we're just going to jump to the middle of the screen, set the heading, and go forward to draw lines at each of the possible 60 angles. These are all of the possible angles that you can achieve with the little turtle. So you can think of it kind of like marks on a clock, like minute or second marks on a clock. So it's really easy to remember, the 15 is like a 90-degree angle, 30 is like doing a complete 180. That's the idea. So the code behind this sine function, this is my original implementation, is just a table of 15 fixed point values, so 1 byte per entry, and it's just the the sine as a 8-bit fixed point value. Some of the poor choices made in this implementation are there's a bunch of mods happening, 3 different mods, which is a pretty expensive operation. And so Julian, I posted this to a forum, and Julian was nice enough to look at this code, and he, offered some suggestions. And so this is some of the things that I learned while working on it. One of his first suggestions is instead of a sine, what if we used cosine, which has the kind of nice property that cosine of x is the same as cosine of negative x. So right off the bat, we can just take the absolute value, and we still have to have one mod to, allow it to wrap. But that's it. That's the only mod in this implementation. So this is a cosine table in reverse order, actually, which also makes some of the other logic simpler. Now we just basically say that, obviously this table is not a complete sine wave. It's just the first, actually it's in reverse, the first half of the first crest. And now you can get the second half of the crest by mirroring, and you can get the trough by negating. So this is what we say is if you're in the second half, then we're going to subtract that from 60. And if you're in kind of the second quarter, I guess that is, then we're going to negate. So we leave this -1 on the stack and subtract from 30 to shift everything over by half. And otherwise we just leave a 1 on the stack, meaning it's going to be positive. So then in the end, you just look up from the table, add 1, everything's off by 1, and then multiply to set the sign. This is actually one spot that possibly could be made more efficient, but this implementation was several times more efficient than mine, which was pretty cool. the other kind of silly point that Julian made, I mean, not silly, his point isn't silly, my code was silly, is my original implementation, I'm doing all of these, fetches of the X and Y coordinates and updating them, fetching and storing, and then calling draw, which does a fetch again, and then calls chord, which, does the fixed point math by literally dividing by 256. And this is all inside of the loop as it marches forward pixel by pixel. So his idea was, how about if we just unroll all of that? It looks a lot more complicated, but essentially we can just do all of the fetches up front once, and then inside the loop you don't do any fetches or stores. You use shift 8s instead of division for the fixed point stuff, and then after it's marched forward, then you update the X and Y. So if you tell it to march forward 100 pixels, it's going to do one set of fetches, sit in this loop 100 times, no fetches, and then update the X and Y only once it gets to its final destination. So this was maybe 15 times faster than my original implementation. So it was a good learning experience. It's pretty interesting how just changing the algorithm can have a huge impact on performance. And so ultimately, I had some silly goal to try to get this all packed into one source block. So reducing the names of the words to single characters, so like T for turn, F for forward, that kind of thing. This all fits in one source block, just a 25 by 20 character source block, which is pretty nice. You want to load up this library, just load a single block, and then you can start to use it. So you saw the demo, but here's like some of the code behind some of those patterns that we were using. So you can see how simple it is to use. So here, I guess we're starting out at -50 by 50, and for 20 times, drawing a 100 pixel line and offsetting by 20 ticks each time. It ends up with this pattern. It's kind of cool, very simple. And I think this is, completely doable by, maybe young teenagers or junior high, kids. It'd be kind of a cool thing to hand this to kids. I handed it to my son at the time, and he was younger then. And it was great. He had fun playing with it, actually. Here's a little bit more interesting one. We start out with a 0 on the stack, and for 50 iterations, we just add 2 to that each time and go forward by that amount. So it's a growing amount each iteration, and turn 14 ticks each time. So each time around, it's moving further and further out, and it does this interesting little pattern. Looks kind of like a rose or something. Drawing a star is very easy. 5 lines, just 80 pixels long, 24 ticks between. And you can just draw 3 of those with 20 ticks between those and get several stars on the screen. Even though all it can really do is straight lines, obviously you can achieve a circle just with lots of little turns. So 60 times, going forward just 4 pixels and turning just 1 tick at a time draws a pretty nice little circle. And we can draw 15 of those with 4 ticks between each, and you get this nifty spirograph looking pattern. So I guess this is the most complicated one. It'd be a little bit of a pain to type that in on the 8-key keypad, but a single pedal is 15 steps of little 5 pixel lines, 1 turn each. So it goes forward, turning to the right 1 tick each time, and then it continues forward another 15 steps, turning to the left. And then so to complete a pedal, you basically do that and then turn 30, which is a 180 essentially, and do it again. So it goes like this and it comes back. That's one pedal. Do that 15 times with what, 4 between each, and you end up with this little flower. It's pretty cool. So Julian actually took a lot of interest in this, and he took some of the same Turtle Graphics routines to draw these patterns, and he wrote it in proper logo on the ZX Spectrum and did some performance testing. And so you can see, the Fignition beats it handily in every single case. Most of these that have a lot of straight stretches, straight lines with not as many turns, it beats it by, an order of magnitude easily, 8x, 13, 12x. And for the ones that have a lot of turning, like these, these circles are 60 times of turning 1 degree each time. Or this one has a lot of turning also. These take minutes on the ZX Spectrum and take just a few seconds on the Fignition. So it's like 35, 36 times faster. Much, 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 much faster. It's not really a fair comparison, I guess, because logo is interpreted and it's on the ZX with proper floating point math. But this shows kind of the power and simplicity of just this ridiculously tiny implementation in Forth on this tiny little machine. And it's way faster than the ZX, which is pretty cool. So here's the project. This is Julian's site, has information on the Fignition, the firmware, and a bunch of examples are checked into GitHub. This is his GitHub. And there's something called the Infuse bundle that offers a bunch of software that comes pre-flashed on it. And actually it turns out that this little Turtle Graphics implementation is in Flash if you buy it through RS Components. And then just this code and this presentation and stuff are on my GitHub here. So it was a pretty fun project. It was really cool to have a completely standalone little dev environment on a board. It's totally satisfying to just solder this together and plug it in and have this thing working, and to just write fun little things for it. And it was pretty cool to hand this to my son and see him programming in Forth as a teenager, young teenager at the time. So I think it's pretty viable as a kind of an educational tool also. So anyway, it was fun.
Okay, thank you very much. So, are there any questions to Ashley?
Just a request. Could you post the link in the text?
Yeah.
I'd very much like to get that code. This looks really cool. I didn't know that's how it worked with the T function.
Certainly. I'll paste it right now.
Lovely, thanks. Looks really good. Is it okay if I incorporate it in my Colorforth distribution?
Absolutely, certainly.
Okay, cool.
So Ashley,
hi, Philip Eaton here. Just Ashley, that was really interesting. I mentioned in the chat, I play with a video game console called the Vectrex, which has got a vector monitor. That also has a logo implementation on a cartridge that was available in the 80s. And having looked at the code inside the BIOS of the Vectrex, it's got 64 angles for a circle. So it's got similar sort of restrictions in terms of its sign table. It's a sign table that's in a handful of bytes. It needed to have when it only had a 4K BIOS. So yeah, it's quite interesting to see your presentation. Similar sort of thing. Thanks.
That's cool. Yeah, logo would look cool on a vector display too.
Yeah. Yes, Ashley, I have a question concerning your cosine implementation. So why is it not just 90 swap minus sine?
Let me look at the code here.
So I always thought that they are just phase shifted. So if you do it the other way around, that.
I don't know. What did you say again? I'll look into that actually.
90 swap minus sine. So if you look at how sine works, then on 0 degrees it's 0 and it grows to 1.
Yep.
And cosine is on 0 degrees is 1 and grow and shrinks to 0.
Yep.
Symmetrically. So I thought it might just work. So maybe there's some reason because of the tables that you use that this is not appropriate, but.
Yeah, I don't remember exactly, actually. It was 9 years ago writing that, and I can't off the top of my head see from the code, but yeah, I'll try that actually, see if that's equivalent.
Okay. Any additional questions? So exciting. I definitely need to have a look at the Fignition and see how it works and how it feels if you work on it. Great,
Yeah.
thank you very much for the presentation. Right, so and then I learned that Julian already left us. I don't know where is he located. Is this also in the Eastern Hemisphere? So then it's already in the night, and not everyone is so night owl like Peter is. yeah, so he is not with us, so maybe he can talk about his Fignition experience next month. And so we have another talk by Xuyang, and it's the force compiler for the LLVM. So Xuyang, are you there? Yeah, there. So are you prepared to show your slides? You have to no? You're unmuted, but we can't hear you. No, I can't hear you at least. No, silence. Let me check. What Zoom says about your microphone status. Where are you? Yes. Yeah, so Zoom does not show that you have a microphone at all. So I don't know, maybe you, as you did, leave and reconnect. Right, so let's see if that works then. So there he joins again. And
hello.
Hello, yeah, that works now.
All right. I think my settings were just set too low. The input volume was not very high.
Okay.
All right. Then without further ado. All right, so this is compiling Forth, and before I start, I just want to preface that on some systems, sometimes you just want a plain old interpreter, something simple that you can work with, and that's okay. But in some other cases, there's cases when you want to use Forth for speed, and that's when you compile. So it's not a all sizes fit solution, but it is a good tool for certain cases. And so the reason we compile, I'm sure it's just the same old reasons that everyone always thinks about. You want speed, but more importantly, you want speed with portability, right? I mean, assembly is always a solution, but of course, once you start writing assembly, then it becomes hard to read and you can't move from system to system. And so one of the goals of this project was to write standard Forth, unoptimized Forth without any special speed constructs, and be able to have this code compile on a range of systems without having modifications. And so why make another Forth? Well, there's, as I'm sure we all know, Forth2020 does compilation, and there's a whole bunch of other Forth interpreters that also have compilation support, but they always miss one of these things. And I'm not sure why, it's just a pattern I've noticed, because if they're fast, then they only support one platform, or they're not portable, or one of them. They're always missing one of them. And so you might ask, well, what is the magic that you're introducing here, Sean? What is the magic that allows you to accomplish all three? And it's LLVM. LLVM, contrary to its name, is not actually a VM. It's a compilation toolchain. It's a library that allows you to generate code to a certain target architecture. And as you can see, it's quite popular. I think a good deal of major languages do have support for LLVM, and LLVM itself does compile to pretty much any system, any architecture. And so it's very powerful. All LLVM-S, in order to use it, all you have to do is compile your language into its pseudo assembly representation. And that's what this project's about. Yeah, and so here's a visual of it. LLVM IR, the difficulty here is that I'll mention it later. Yeah, and then basically one of the selling points here is that as soon as you can convert to LLVM IR, you also unlock all of the abilities of LLVM, like compilation, target generation, link time optimization, everything. And I think as you can see from here, any optimization you can think of that Clang has, Clang is one of those, one of the major C++ compilers, you can apply to this fork. So it's very cool, almost like magic. Without being too controversial and without trying not to offend everyone here, I make a naive observation that a lot of Forth code involves stack juggling, and sometimes that's okay, but it is wasted cycles. So what I'm trying to do here is to convert everything to registers and to see how much better that performs. But I do want to say that sometimes stacks are better. There is actually, in fact, a past Forth compiler that uses LLVM. It's called LL4th. You can find it on GitHub, not by me. And it does, what it does is it compiles an interpreter and a dictionary into the final executable, and that obviously impacts the speed. So what I'm trying to do is to not have any of that. So no stack, no dictionary, no interpreter in the final executable, just the final optimized stripped down code. And some of the difficulties I had here is that LLVM was originally part of the Clang compiler. That was the original use case of LLVM, and so it was designed for a language that had functions and had registers. And obviously that doesn't work well for Forth is stacky. And so one of the difficulties here was to map stack transformations to registers. And there are a few hundred lines of code to do that. So if you're interested, you can always check the GitHub repo, but I'm not going to get too deep into it right now. And like I said, the second difficulty here was that LLVM takes functions. And so in order to do that, I have to know ahead of time the number of inputs and the number of outputs from each function. And Forth function doesn't have any of that. So there is a few hundred lines of code to also do that. And I'm not sure how readable this is, but it's just sort of a pseudo assembly. The reds. Yeah, I will see. There's not much to it. There's the variables prefixed by a % are registers, and registers can be any type. Then we have the green calls. Not that fluid in assembly, as you can tell, but I think a lot of people here can read that without too much difficulty. And this problem is actually harder than you think it is. I know reading the old Fourth Dimensions archives, there are some people who have done this before, but in my solution, I have to think about loops control flows. And so sometimes you get two basic blocks that merge into one. And in that case, you have to make sure the register names all match up, and that's very difficult. Here we have a simple do loop. And in this case, the Forth compiler compiles this into LLVM pseudo assembly. And as you can see, there's no stack operations here. It's all registers. And what's interesting is that on this line, on the third line inside the loop block, the compare actually writes to the new counter register, which is actually first used up top. So there is a little bit of register merging there, where the code can figure out, oh, I'm using the register that was present before, in which case has to be aligned. And so some other challenges I had was how to handle compiling words, because as I said, the final executable doesn't have a dictionary or an interpreter or a stack or really anything. So the only way to handle those ifs, else, thens, repeats, loops, and immediate words is to do them during compile time. And actually that's very powerful because you basically get you can basically get full compile time functionality. There's no limit on what you can do during compile time. You can evaluate a whole program during compile time, and that would be possible. And in comparison, a lot of other languages don't have such. They have a lot more limited and often a lot more complicated compile time semantics, like C++. There's actually a term for that. It's called template hell in C++. And instead of just showing slides, what I'm going to do is show the actual output of the compiler. And I'm sure actually reading the assembly will be a lot more helpful. Here I have the move forth code. In a bit at the end, I'll give the link to the GitHub and you can clone it and build it for yourself. But anyways, I've got a folder full of examples. And first, let's start with something simple. Let's just start with an minute. We have the simplest of forth codes. All it does is print star. So I'll compile, and we get a lot of debug output. But first, what happens is the compiler compiles the Forth source code into LLVM pseudo assembly. The official term for it is IR, but I think pseudo assembly is a better word for it. And here we get a function main in which there's only one thing that happens, and that's a call to printf. I could have used another system call such as puts or something, but printf was more convenient for debugging. So that's all it does. It just calls printf and it passes 42 to printf. The next step in the compilation is to compile to assembly. In that case, we get such. And I'll leave that on for a bit. I myself can't really read assembly, but I know a lot of people here can. And this part is not part of. This is part of LLVM. The assembly generation is part of LLVM. This is not the code that I worked on. And that's actually part of the magic of LLVM is that everything just works. You don't have to worry about the particular target you're compiling to. You don't have to worry about the architecture. Everything is handled in LLVM. And finally, this assembly gets linked to the standard library. And finally, we get an executable. So, which case? And assembly here is a lot or the machine code here is a lot longer because we've obviously linked to the standard library. And so yes, the code does work. Now we get a 42. And so I can do some more complicated things such as compiling stack operations to registers. So here we've got a simple swap. And that works as expected. And the cool thing here is that the pseudo assembly, we've actually applied optimizations to the pseudo assembly. So in this case, there are actually not even moves between registers. All we have are just constants. And yes, like I said, any optimization you can think of that Clang has, that Rust has, or like that Ruby has, you can also use here. Oh, and here's the assembly for anyone interested. So then now we can get into some compile time words. Have a implementation of a loop. And here we have a mark, resolve, a while, and somewhat unconventional, a repeative. But essentially what it does is a do loop. It's a do loop. So if I compile this, in the pseudo assembly, as you can see, we don't have a mark function or a resolve function. Both of them are immediates, and they've all been run during compile time. And what's interesting here is that, unlike other languages, our compile time semantics aren't limited to just compiling constants or type templates. Here we've actually, if I show the code again, here we're actually compiling words into the definition of main. And so I just thought that's very powerful. And here in the pseudo assembly, we have, as expected, a loop, a branch, just as you would write a loop by hand. And just to prove that, yes, the executable does work, we have a loop here. And what I can do is make the loop much bigger. Yes, it is very fast. Oh, and looks like there are some comments in the chat. Yeah, so in the final executable, there might be a stack. The pseudo assembly is completely register based, but if LLVM decides that using a stack in the final executable would be faster, or the registers have overflowed into the stack, then yes, that does happen. But fundamentally, it's a register machine. Oh, and yes, you might ask, well, what happens when there are multiple words? Does it compile multiple functions? And for the most part, it does. But I think the most recent version of the compiler actually inlines the smaller definitions. Oh, wow, there's a lot of garbage in here. Essentially, what we have is an if true, it prints 32 twice. Otherwise, it prints 42 twice. Yeah, there you go. And I think last night I had more to say, but I didn't get enough sleep, so I'm sorry if the presentation is running kind of dry. Here we've got a Fibonacci code, and once again, we do have a lot of compile time words, a lot of control flow words. And Fibonacci is especially criminal to the use of stack operations because at the very core of it, Fibonacci is just adding two numbers together and then storing it in a third register. But to do it in a stack machine, you have to do lots and lots of juggling. However, after compilation, we don't have any of that anymore. And pseudo assemblies here. All we have are calls to printf and register assignments. It's very powerful. And I won't bore you with the rest of it. So let's. And so in conclusion, I spent, in total, I spent about a year on this, but as for like the bulk of the work, maybe took about 3-4 months. Most of it was learning LLVM, which is actually surprisingly simple. And at the end, this is really just a proof of concept. There's still a lot of rough spots to be worked out. For example, it only supports a very small subset of primitives. And the primitives supported during compile time are even less. However, I'm sure if someone actually put in serious effort to it, like they do with Forth2020 or WinForth, it could become very fast. But as it is right now, it's portable in that you can compile to any of the targets on this list without having to change your code. There's no assembly in the source. However, it is pretty fast. You can perform very powerful optimizations on it. And once again, you might not always need to compile, but in the cases that you do need performant code, that is possible too. And as a footnote, if you still want an interactive shell like you do with Forth2020, that's possible too. Just compile. You can compile specific words interactively. And actually, in order to perform all of those compile time operations, there is a full Forth interpreter inside the compiler, which is kind of ironic. And if you want to link to other languages, LLVM does support the CABI. Yeah, and that's all. I didn't get a lot of sleep last night, so that's pretty much it. Feel free to email me with questions, your source code. Fork it, branch it, do whatever you want with it. Thank you.
All right. Thank you very much. So that's very interesting. Are there any questions?
Christian,
I've got one.
When using a Forth compiler instead of a typical Forth with an interpreter, are we losing anything? I saw that at the beginning, someone showed us a Forth without an interpreter that compiles interactively. Is this possible with what you have? Do we lose the interactive part? Am I online?
You have to unmute again.
Oh, I'm sorry. That's embarrassing.
Did you hear my question?
So in terms of interactive functionality, you don't lose anything. As of now, the interpreter doesn't have any interactive functionality, but with a little bit of work, you can add that in. And the interpreter can just be an old standard interpreter with a little bit of compile time abilities tacked on. So you don't lose anything. All you get is speed.
So you would do something similar to what the gentleman at the very beginning did with the propeller. I don't know if you saw the presentation.
I'm sorry, I wasn't here.
Okay.
At the beginning. Yeah.
You were working too hard on your own. Thanks.
But as for what you can run, the words that are supported during, like in the compiled code, yes, that is limited. Because obviously, if you're trying to compile words that depend on the dictionary or depend on the stack, that doesn't work.
I think I want to make sure I got this right. You created a compiler, which is basically a new source code for LLVM, a new Forth source code, so that you added a part to the source code compatibility of LLVM. Is that it?
Yes. So what
And LLVM is basically a virtual machine that has its own assembly language.
So LLVM isn't a virtual machine. It's just a confusing acronym. Oh, it's actually not an acronym. It's just a name. But LLVM, what LLVM does specifically is it takes in its own pseudo assembly format, and then it writes machine code to a target of choice. That's all it does. The input is pseudo assembly, and the output is executable. And then as for the part that converts from Forth source into LLVM, that's the part that I write. That's what Clang is. Clang is a converter from C++ into pseudo assembly. The Rust compiler compiles from Rust code into pseudo assembly. So that's not part of LLVM. LLVM is just the executable generation.
Okay. Thanks a lot.
No problem.
I have an observation since Forth uses a two-headed dragon because of the stack juggling. I find it interesting that LLVM uses a single-headed dragon, maybe because it uses registers.
Yeah, funny.
And to be pedantic, it's a wyvern. It's a wyvern. They say it on their trivia page.
Okay.
I think they chose the logo because dragons are flexible and powerful or something like that.
Mm-hmm. All right. Any other questions?
Yeah, I've got a question.
Sure.
So this is quite interesting. It's a way of taking some Forth source and making it work on lots of different targets, all relatively modern. I wonder, I mean, you had a triangle of features of your Forth, and you said that there was always one of them that was missing. I thought it was quite an interesting way of looking at it. I suppose I'm not sure. Yeah, here we go. Readability, portability, speed. There isn't one on there called size, which might be relevant, probably less relevant these days, I suppose. But if you're looking at some of the smaller microcontrollers, there may be. But the question I've got really is to do with the speed part of it. Have you tested the speed of your Forth source on the target compared to a regular, maybe a Forth written in C, also running on the same target? Are they comparable? Is yours faster? Does the optimizer in LLVM actually work? Does it provide you anything tangible? Have you done any comparisons? Excellent presentation, by the way. Very interesting.
I haven't. Benchmarks are definitely on the horizon, and if you come to the SVFig meeting, I will have benchmarks. However, if you ask me to estimate how fast it is right now, it might be a little bit less fast than most interpreted Forths, just simply because the code isn't very mature right now. But the optimizations in LLVM are solid. They're the same optimizations run on C code. So with a bit of work, it can be. And I know this is a big claim, but as fast as C or as fast as C++, because it's using the same, fundamentally it's using the same compiler library.
Mm-hmm. Yeah, I mean, I think the big question you're posing here, or trying to understand the answer to, is all of the other languages that are listed that feed into LLVM are probably based on Algol, which means they're all the same, roughly. I mean, I could be wrong. I don't know all those languages very well, but generally speaking, they're all based on Algol. They're all like C. So you're basically compiling down to something like C.
Yes,
Forth is not like that. Forth is very different to that.
Yes.
And the question is, can you still make it work? And I find that actually quite fascinating to see what your results will end up being, whether or not they can be optimized without going to a whole load of effort to make it such that the speed is important. The reason I mention that is I don't know if anyone's looked at the Dave's Garage software drag racing on YouTube, very popular channel it would seem, where he's got I think it's a prime calculation that he's running on all different sorts of languages to see which ones are the fastest. And Forth at the moment is someone's put one on there very bravely. put a fourth implementation of the algorithm that Dave's chosen, and it doesn't do very well. Basically it's about as fast as all the interpreted languages like Python, which honestly is very disappointing for Forth because it's supposed to be relatively quick. Now, if something was optimized, and there aren't many Forth optimizers that aren't commercial. The one that's been tested out so far is not one of those. This is one way of doing it. This looks like it's a non-commercial potential for a non-commercial optimized Forth. It's got a long way to go, but I think that might do something to restore the prestige of Forth as being a fast as well as flexible and special language for certain circumstances. So yeah, I look forward to seeing.
I would say that would probably be a really good thing for you to benchmark, is to try to take that Forth source code and compile it and then run it and then see how quickly it can calculate a prime number. That's
yeah. Dave's Garage YouTube channel is where there's links there to what he's got on GitHub, and there's about 60 or 70 languages on there where they've compiled the same program or the same algorithm written in different languages, and then they've got some tables that you can sort and filter on for different processors, different languages, and compare the speeds. And I think that'd be a great way of benchmarking it, because it's a relatively simple algorithm. You probably could implement it with what you've already got.
Yeah, and I will have those benchmarks at the SVFig meeting. So come, it's Forth Day.
Yeah, great. Yeah, good hint again. Are there any other questions? Oh, looks like it's very Forth weeks these weeks in fall. Like we have our meeting today, Forth-Tagung takes place. Next week we have SVFig. So whenever you want to hear something about Forth, then you can join a meeting. So that's nice today. So if there are no additional questions, then this concludes our meeting for today. And I'm quite happy that we were almost on schedule, and almost thank you for everyone who has been talking to try to keep in the 15 minutes limit. We learned from Bill why this is important. And yeah, I think we are more or less at the end of our meeting for today. Yeah, I would say we can continue some discussion for a couple of minutes, and then whoever wants to drop out, just wave your hand and or say goodbye in the chat, and then we're done. Thank you very much for joining this time. And so I think it's just a free dropout and saying farewell now. Have a good time. Thanks. Nice meeting. I like that.
Hi, Sean. Where are you? How's the crowding? Sunday. Yeah, I see that you are in a dorm.
Yeah, I think I woke up my roommate, but he was supposed to wake up a few hours ago, so it's okay.
How's the school?
It's hard to explain. You're not the first person to have asked that question. There's a lot of cool people, a lot of cool technology.
Good to see you anyway. Yeah.
What university are you at?
Purdue.
Oh, okay. Boilermakers.
Yep, Boilermakers. There's nothing around except for the school, only corn. That's really it.
Are you a computer science major?
Yes.
What year are you in?
Freshman. I'm a freshman.
Just be careful, keep up with your schoolwork. Sometimes, at least it was for me, I got distracted with stuff in computers and let my schoolwork fall behind, and I finally completed my degree, but it was like 30 years later. So it's important to get a degree. So I think you're well on your way to a great career.
Thank you. I mean, at the moment, the course load isn't that hard, because at least for first year courses, it's targeted towards like people who might not have programmed before in their entire life. but I'm sure next year or the year after that, it'll get a lot harder.
Well, I wonder, can you inspire, and are you able to inspire any other students with this fourth language? They're probably, they probably love Python and the modern languages. I mean, the thing I find very interesting with Forth is it's really almost a step above assembler. And I think assembler is an important language to understand, because that's actually what the machines are actually executing. So,
I mean, here we do have a compilers group, and there's a big, there's a lot of people who are interested in pursuing the compilers track inside the CS degree. And in fact, actually on this project, there's a graduate student at Purdue who has been a great help to me. But as for most CS students here, if I show them Forth, they'll go to sleep, because a lot of people, we're not interested in what language we use, as long as we accomplish what we need to accomplish. For example, there's a race car group here, and I don't think they care what language they use as long as the car goes fast. And
well, yes, I think you demonstrated several meetings ago. Didn't you have a robot that you had like a Forth command line interface to?
Oh, yes, yeah, that was a few meetings ago. That was in my robotics team, which I'm no longer a part of.
Oh, but no, I thought that was a very practical and good use of Forth. I mean, it allows you in a command line to do some pretty powerful stuff with some, with a compact language. So
it was a good idea, but I think the problem with using Forth in a lot of modern applications is that in the end, there's not a lot of support for it. Because when I left afterwards, the software division in that team switched back to whatever tools they were using before, simply because the other tools had more support. The editor, the IDE already supported it. It had syntax highlighting, all of it. And if you needed help for the other tool, it had lots and lots of documentation, lots and lots of support. But if, say, you ran into a problem with my command line Forth, then no one could help you.
yes, no, you're right. Yes. And Forth can be very picky. A missing space, you can have, if you leave something on the stack or don't, take stuff, you take too much off the stack. Yeah, it can crash. So. But thank you very much. I really enjoyed your presentation.
Actually, as for leaving stuff on stack, in my compiler, there's enough static analysis that if you do something weird like that, the compiler will warn you, oh, hey, I don't think you ever use this variable. Consider dropping it or something like that.
No, that's a good point. I mean, that's problems really in a lot of languages where you can have memory leaks, and part of the issue is those bugs go undetected, and they get released, and it's very true that that's why testing is important. It's the faster or the closer to development you can catch a bug, the less amount of money it's going to cost your company or supporting something in the long run. So
that's a good point.
I don't know. Is Peter, are you still on? I think you were earlier.
If you mean Peter Forth, no, he had to drop out about an hour ago.
Or Peter, Mr. Tachyon.
He's got an empty seat. Who knows? He's probably fallen asleep. He's on the floor.
Oh, okay. No, because he has a version of Forth that runs on top of. I guess he calls it a .fth file, but I guess it's a like a Forth file that Micrisp Stellaris, which is like an assembler implementation of Forth that runs. I'm interested because I'm playing with it on the Raspberry Pi Pico. and then you can load his Tachyon on top of it. I guess it gives extra, it changes the prompt, and it, I guess, gives extra words to the Forth implementation. I was just wondering if you might want to talk about that, or that might be an interesting topic for a future meeting. So are those the cows? I see your background in Zurich there, the grass and the cows. Is that?
They're actually Highland cows from Scotland, but
oh, okay.
Where I used to live in Switzerland, that's what was outside. For some reason, they imported a whole load of them over, and they lived behind where I lived. So
very nice.
They're not standard here. The regular cows are milker cows, grey and white ones.
This is Christian. I have a question regarding LLVM. Is Mr. Chen still there?
Yep.
Okay, so my question is, what is the development platform for LLVM? What does it look like? How do you use it?
It's C++. It's a C++ library. If you'd like to take a look at the source code, I think it's on the Facebook group. But I mean, it's really just a library. You make calls to LLVM. You tell it, oh, I think it's LLVM dot dump or something, and it spits out all of the machine code.
There's not really a development platform or an IDE. It's just a place where you drop code and you get code out.
It's not like Forth. It's not typically for C++ code, you use your own IDE. LLVM is just a library, really. So as long as you have C++ in some shape or form, you can use LLVM. And so myself, I use CLion, but some other people might use Emacs or even a simpler editor.
So any IDE that accepts C++ could generate C++ code that will be translated by LLVM to whatever you want.
Yes.
Okay. Thanks. Do you know if it supports the Extensa CPU used in the ESP32? It doesn't show in the diagram you showed, but
is the ESP ARM? If it's ARM, it does support.
So the ESP32 is not supported?
Does anyone here know, is the ESP, what's the architecture for?
Yeah, it's an ARM based
and it is supported.
Processor.
Yes, it is supported.
It's an ARM base? Okay,
yeah.
So then it'd be supported. Thanks.
At least I think it is.
ESP32 is a very strange processor. Like it's a very strange one. Okay, it's not ARM. It's a 24-bit processor.
Oh, I apologize then for bad information.
Yeah, very strange. You can talk it to it in assembly. I think C and C++ is the best way to talk to it.
So, Dr. Ting, when are you going to provide us with a new Forth that runs on LLVM translated to? It looks like you've tried everything except this one.
Well, I would have to say if C++ can compile to that, it's probably using LLVM under the covers to compile to that chip. So I mean, I'd have to research that, but because it's the standard C++ tool chain, isn't it? Or
for C++ compilers, there's this one, Clang, which uses LLVM, and there's also GCC. GCC is part of the GNU project, and there's a huge debate about which one's better. And unless you want to get burned on a spike, you probably shouldn't give a preference. But I like Clang. I like Clang.
No, that LLVM is obviously a real good portability tool.
Yeah, I think the story, as I know, was that the ESP32 was developed by some engineers in Shanghai. And I think they enlisted help from a Russian to move the system into Arduino. Okay, so I think they wrote the C++ compiler for it, and then incorporated into the Arduino system. And then you, on the Arduino, you can write program basically in C++, and it will compile and run on the chip. But the underlying CPU is very strange. I couldn't understand it.
See, with that new Forth compiler, we could effectively write Forth in Forth.
Well, everybody's writing Forth in Forth, but I think now with the experience in working in JavaScript and Java and C++, I think, you know, it is with the underlying compiler and operating system, it should be quite easy to write Forth in any of these languages and operating systems. And the Forth writing in these native languages will be much simpler and much easier to run on these various target machines. Okay, hope to see you guys next week. I really, you know, the SV thick is getting smaller and smaller. This group is much bigger than the Silicon Valley big group. So I hope that everybody will move on to that platform as well. Okay. Yeah, see you next week.
Yes, I'll see you there.
So goodbye, everybody. See you the next time.
Yeah, take care. Take care.
The SV Fig is open to anyone, right? Do you have to be a member or?
No, it's open. No.
Okay.
Okay. Before everybody goes, I have a hardware question. Does anyone know an N-channel MOSFET that accepts 60 volt, 10 amp, and can be controlled to saturation with a 3.3 volt logic level? Most of them work above 10 volt level, and there's no logic device at that level.
I worry that I'll electrocute myself if I play with something like that. I'm joking. I'm being sarcastic. I apologize. What are you trying to control?
I'm trying to fix a food sealing machine.
Ah, okay, okay.
That is controlled by a 3.3 volt microcontroller. And the transistor in there has a part number that I can't find anywhere.
So you were able to troubleshoot it, or does the transistor burnt out? And was it
I'm trying
obvious
to
that
troubleshoot the food saver.
Oh, okay.
I don't even know the processor that is in there. I could identify the processor and I could not identify the.
Oh, you know where you may want to try
the
is on
MOSFET.
Stack Overflow. They have an electronics question and answer form. You might be able to post your question there and get a. Are you familiar with the Stack Overflow websites?
Stack Overflow? Yes, I saw it.
They have an electronics. Let me see if I can find the name of it. It might even be electronics.stackoverflow.com. But you can post electronic questions there and.
The original MOSFET is an SSM 9971. I have all the specs, but I can't find it anywhere.
Oh, okay. I'm sorry. Go to electronics.stackexchange.com. And you can post. You have to join it, and then you can post an electronics question. And
okay, so thanks a lot.
Good luck. Maybe we'll be able to program your food saver with Forth if you can figure out what the microprocessor is.
I had that in mind, but I don't see what would be the use of programming a food saver.
Take care. Goodbye, everybody.
Goodbye, everyone. That was a great afternoon. Thank you for all the chat. Really interesting. See you another time. Bye-bye.
So it looks like there's no more chatting. So I'll say goodbye, everybody.